Sisileleli Africa, Maluparadisu Kondonayo, Israeli Jana Soyetu, Osi Silelela China, Lusapolayo, Urena Buluka Sechama Saesu, Usibuluke, sichamasa, Jesus, sichamasa, South Africa, South Africa. Sounds the call to come together, and united we shall stand. Let us live as one for freedom in South Africa.
Oh man, what a way to start the session. We start in God's name. We invoke
Let me
His
tell you a
name.
secret. I use inverted elements to produce over 2,000 videos a year.
Sorry about that. Let's start in God's name. Let's invoke His name. And maybe have a successful session that benefits the class of 2023. Sawubona, goeiemôre, good morning, namaste, assalamu alaikum wa rahmatullahi wa barakatuh to one and all across South Africa. This is a program for you. If you are in grade 12 and you're having some issues with your mathematics, this is the session that is going to prepare you for your June examination and more. We had some fun yesterday. We hosted the grade 12 maths paper 1. Today we are doing maths paper 2. Where Mr. Kota is going to be dealing with geometry as the subject. A very warm welcome from myself. My name is Hasanain Abdullah. I'm the project manager for Awqaf South Africa. So Awqaf South Africa is a community-based organization, and through lots of our sustainable projects, including setting up PC labs, boreholes, and cataract operations, we are here to rebuild South Africa, and through our integrated and sustainable projects to assist South Africa so we can be great again. So this project that we are hosting today, the Maths Workshop, we've been doing this Maths Upgrade Workshop since 2016, and it's our aim to assist grade 12 learners, grade 10, as well as 11 learners with their mathematics, because we have found that some of these learners have been struggling with their mathematics. Do us a favor, do subscribe and like this video and subscribe to our YouTube channel. We do have some other workshops that's taking place during the course of the week. And please hit us up in the comments and let us know from which city you are connecting to us from, and from which school you are connecting to us from. Also subscribe to our Facebook, Instagram, and Twitter. The hashtag is Awqaf SA Maths. Please do send us a few photos of you engaging with the system. So now we're going to be calling on Al-Ghazali College principal, and he will be addressing us, Mr. Muhammad Ali Riza. He's been very instrumental in mobilizing lots of the in-person participants and we are hosting this session in person at the Al-Ghazali College in Pretoria. So I'll be calling on the principal to address us. He'll be telling us a little bit more about how the session went yesterday, and he's been very involved and tirelessly himself and his staff they've been preparing and putting together this in-person session. So let's call him on. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum salam. You okay?
Alhamdulillah, I'm well. Just let us know what's the energy like at the school and what was the session like yesterday. We know that you and your staff have been very involved in putting this program together. It's been lots of hard work. So just tell us a little bit more about what the vibe is like at the school this morning.
Right. Firstly, I think I've spoken to a lot of students here. We attended yesterday's session, and the feedback I got was extremely positive. It was a very exhilarating session, very motivational. We were very impressed with Mr. Kota and the way he handled the issues, and also the pace and the momentum in which he delivered the lessons. And from what I can see here is that because of the attendance quite early in the morning, and I have to congratulate all these young learners for coming in Sunday morning. It is not an easy thing to wake up and it's quite cold here. And I give them a yes, round of applause for them. So Mr. Kota actually executed the content he's delivered. He had them all on the edge of the seats. They were all very happy and chatted with them. Even the teachers were quite impressed. And also my team here at Ghazali College were always hands-on. I really thank you for that. And I thank also the children here who came in today, because it's you that makes this program a success.
No, that's fantastic, and we're very grateful to you for putting this program together, because we have to invest in our future. And what better way is investing and assisting our grade 12 learners? Any concluding remarks?
Today is the second session, and I know it is quite a long session. So I wish that, I just hope that our learners will just stick it in there and try and get the maximum benefit. And I like to thank also Mr. Koda for his unwavering enthusiasm and motivation. And this man seemed like he can go right for the whole week without any sleep. So I thank you both, and I thank you also Hasanain and the Awqaf team and the Kway and iSkill and our Ghazali College. We work in a nice partnership for the benefit of our children, because that's where our investment is, as you say, in the future of the country. Also, inshallah, rests upon their shoulders. So, inshallah, we also ask Allah subhanahu wa ta'ala to bless us.
Ameen.
And we make shukr, and we are thankful for everything we got. We are thankful. And I also want to open this invitation to all the schools that if we have any problems, we can work in partnership, because this is our common problem. We have a common task ahead. All these children are our children. We don't distinguish. So you are one, let's move towards unity.
So there we go with Mr. Muhammad. So we're going to produce more doctors, scientists, and lawyers from this cohort and so on. So we thank you, and we're going to hand over to Mr. Kota now.
Okay, thank you, sir.
Okay, so in preparation for our session, before we call on Mr. Kota, we're also going to remind you that this session is hosted via Awqaf's Facebook and YouTube. Do subscribe and like to our channel, so you won't miss out another session with Awqaf and Mr. Kota doing his thing to assist our learners. So I'm going to call on Mr. Kota. Mr. Kota is the driving force behind the Kway Institute. And the Kway Institute has been the implementing agent for Awqaf's Maths Upgrade project. So we've been doing this since 2016, and we're going to be calling on Mr. Kota, and Mr. Kota is going to do what he does. But today, we're going to do something a little bit special for you. Before we get started, Mr. Kota, I wonder if we can get that Mexican wave going.
And we got the camera going at Al Ghazali. There's all the Al Ghazali kids, and I think you want to give them a prompt. We've done a bit of a.
Let's go. 1, 2, 3. Yay! Let's go.
Let's go. going right there, and let's start it again there.
Again.
Okay,
Let's
here
finish
we
it
go, here
away.
it goes, here it goes, here it goes. Do it again. Let's go. Stand up, let's go. Let's go. Let's go. Get them all exits started again, and let's get the session on the road.
Here we go.
Absolutely amazing. The
Okay.
energy here is electric.
Okay, Mr. Kota. So we're going to start the session now. So Mr. Kota will be taking you through grade 12 mathematics today. And he is going to be focused on maths paper 2. It's all about geometry. That's maths paper 2. You can view this on our YouTube platform as well as on the Awqaf SA website. We will be loading it. Log on to awqafsa.org.za.
Really.
Don't forget to subscribe and like our platform. Anyway, Mr. Kota, let's get the show on the road. Before we get going, just let's go through the customary what is required. Let's do that.
So they're going to need a scientific calculator, a writing pad, pen, ruler, and the most important thing, hydration. Right, water, sandwiches, fruit and snacks and everything to keep you going for today. In fact, we're continuing, although this is our program, but we ended up, I want to finish up the calculus from yesterday, the cubic graph and optimization, and then we will start with circle analytics. We'll go for break, we'll do trigs, and then we'll end up today's session with Euclidean geometry. So guys, I hope you guys are ready for today's bumper session, and this is our last prep, June exam prep. And then, we regroup again before prelim exams with all your higher order questions, right? And then we will regroup again with Awqaf and Kway SA, where we do our matric final prep program. And inshallah, by then, you should be 90% and above in mathematics.
Mr. Kota, let's do some shout outs for our online attendance. We have some of the schools in the house.
Lovely. Good morning. Online learners, on-site learners, learners from South Africa, teachers, schools, and all our learners logging in from across the globe. We got learners coming in from UK, we got from Australia, Malaysia, and obviously not to forget our learners, our expats from the Middle East, from Dubai. So we got lots of learners. They're also doing the South African curriculum, and they're also logging into our program. So hit us up in the comments from wherever you are doing. Where to Globo, let's Dala Math, Bob Yost, or Bob Ghost, or Bob Ute. You're unlocking your shenanigans. Tabi Mesh, Sedi Bana, Musa Zwani, big shout out. LeBron, you back. You're back and you're better than before. We got
LeBron
Kevin
in the house.
Yeah, okay. And Rhodesfield also wants the videos. So send your videos in. Guys, if you guys are doing a Mexican way to school, send it in. Send it in to hasanain, and hasanain would share during the break. Tapi, are you guys bright, fresh, early, really woken up? Hope you had your morning shot of espresso or coffee, caffeine intake. And let's get cracking. Let's get the show on the road, guys. Let's get. Offense is from America, which I think is the other side of Pretoria. Fourways High School. There we go. Good morning. Ibongo. Let's get Apiwe Nobi. All right, let's get the show going. Hasanain, can we take the show away?
Go for it. You've got to go ahead.
We are bright and fresh and early, fully jet fueled. We're moving with loaded tanks. We've got a big day ahead. Let's get cracking. Now, somebody sent me this while I was driving this morning. As I was getting to the venue, somebody sent from a past paper. It's exactly what I was going to do today. We're going to do the cubic graph. They tell us f of x is equal to 2x to the power 3 minus 5x squared minus 4x plus 3. Take this one down. We are now doing calculus. We're finishing up the calculus where we stopped yesterday. We are doing the cubic graph. We are doing the cubic graph. I'm going to show you how to sketch it and how to find equations. And then we're going to do application, optimization, and that would finish calculus. It means that between yesterday and today, you have finished the entire calculus component for the entire year. Hopefully, if you master it, you're ready to write your final exams. Okay, so what did we do? Just to recap yesterday, we did first principles, the formula. We did derivative. We did differentiation. We did finding equations of tangents to graphs. And if any of you missed it yesterday, go on to YouTube, on to Awqaf SA. The program is live. It's already, yesterday's session is already updated. I had a look at it last night. Okay. Now, guys, let's start. What do we need in order? Now, firstly, you need to know shapes. What would the shapes? Although it says to the power 3, it can have 3x intercepts. So if it's got 3x intercepts and it's a positive graph, the graph is going to look like that. 1, 2, 3 positive intercepts. 1, 2, 3 x intercepts. If it's a negative graph, the n graph will look like that. And that is with 3x intercepts. With 2x intercepts. Sometimes you might get 2x intercepts. Your cubic graph will look like that. The positive one and it will bounce. And a negative graph will come down that way and bounce. With 1x intercept, let's write it here. If you had only 1x intercept, what would your positive graph look like? Would look like that. And your negative graph would look like this. Now, those of you who are writing your NBTs, please make sure you know calculus well. It's tested heavily in your NBT exams. Okay. So, like I'm saying, I'm just showing you what the final graphs will look like. Let's go into our comments. Let's go into the comments. Let's see, are you guys all following? Onliners, are you following? We're now going to sketch this graph. We're now going to sketch this graph. Let's buy. Tulip attending class, fired up. I think you now got. We've been introduced to each other yesterday, so we know what our style is. So the first thing we need to know, in the cubic, what do we need for the cubic graph? What do we need? So you have a checklist on the side. Here is your checklist. So we need a y-intercept. We need x-intercepts. We need 2 turning points. All these graphs have 2 turning points. We call them SPs, stationary points. So we need 2 sets of turning points or SPs, stationary points. So when they talk about stationary points, they're talking about turning points. And then we need what we call the point of inflection, the point of concavity. We spoke about it yesterday, the point of acceleration. That tells you whether the graph is concave up or concave down. We need to show that on the graph. Right, how do we get? So we need 1, 2, 3. We need 4 things before we sketch. So in our answer, let's go. In our answer. Right, take this down. Take this down, onliners and on-siters. Bums on seats or eyeballs on screen. Let's go. How do we get our y-intercept? We say let x equal to 0. So then 0, 0, 0. What is y equal to? Y is equal to 3. Now, I haven't done this question before. Like I said, as I was driving, coming to the center this morning, this was the question that came up on my WhatsApp. So as you guys can all see, let me just unlock that. And I don't know if our onliners can see that. That's the question that came up on my phone this morning. Okay. Now let's go. Now, so we got our y-intercept. So put a tick there. Now this you can write on the side in pencil. Now we need our x-intercepts. Remember, what's important about mathematics is not getting just the answer right. It's about understanding how to unpack a problem. Once you know how to unpack, it's algebra that takes over. Once you know how to unpack a problem, its formula, its structure, right? So if you want to write it, you must know how to unpack a problem mentally. Then its structure, how do you structure your answer? Then your algebra takes over. So if you can unpack it, you can structure it, you can do the algebra, you'll definitely get full marks in mathematics. Unpack algebra or unpack structure and algebra. We can make another acronym, USA. Unpack structure algebra. Right, let's go. So we got our y-intercept. We need our x-intercept, so we're going to use the factor and remainder theorem. Let's try f of 1. Factor and remainder theorem, we're going to try 1. We must get 0 as a remainder. So 2 into 1 cubed minus 5 into 1 squared minus 4 into 1 plus 3. That will give me 2 minus 5 minus 4 plus 3. 2 minus 5 minus 3 minus 4 minus 7. Minus 7 plus, we get minus 4. Therefore, f of 1 is not a factor. We need to get 0 as a remainder. How about we try f of minus 1? F of minus 1 is 2 into minus 1 cubed minus 5 into minus 1 squared minus 4 into minus 1. I'm just going to erase all of this. We don't need it now. We're trying by trial and error. We are doing the factor and remainder theorem. We must get 0 as our remainder for it to be a factor. And then we got plus 3. Let's check. That's minus 1 times 2 is minus 2. That's 1, that's minus 5. That's plus 4 plus 3. Hey, what do we get? Minus 2 minus 5, minus 7 plus 7. What do I get? Yay! I got my first factor. So step number 1, let x equal to 0. Step number 2, the factor and remainder theorem. We want to get 0 as a remainder for a number to be a factor. Our first factor is x plus 1. Why? X plus 1 equals to 0. X will equal to minus 1. Take this down, take this down, take this down. Very good. Sipe Sikle Velakazi. Well done. Well done, well done, well done, well done. Right, let's go. Now we do what we call, so step number 3. So step number 1, let x equal to 0. Step number 2, the factor and remainder theorem. Step number 3, we do what we call synthetic division. Do not do long division. So let's go. Watch how we do synthetic. We take our first factor, we put it outside. We're dividing it into here. So we put all our coefficients inside. Pay attention. So we got 2, minus 5, minus 4, and 3. I must get 0 at the end. Now pay attention. Were you guys shown this in school? Right, so we bring this up. The 2. When we come across, we multiply. Whatever answer we get, we add to the next term. So let's do it all together. So there's the minus 1, your first factor. So there's your minus 1. These are all your coefficients. Now remember, if there's a 0 there, you have to put 0 in its place. It's got to be in descending powers. Power 3, power 2, power 1, power 0. Let's multiply. We're coming across, so we multiply. 2 times minus 1 is how much? Minus 2. Minus 2 minus 5. Minus 7. Now we multiply again. Negative 7 times negative 1 is 7. 7 minus 4 is 3. Repeat. 3 times minus 1 is minus 3. Minus 3 plus 3 is 0. So we don't think we right, we know we right. And there we go. There's your answer on the top. It's cubed. We took out one factor, so this must be 2x squared. 2x squared minus 7x plus 3 equal to 0. Now we factorize that. Equal to 0. That's 2x and x. That's 1 and 3. That's negative and negative. 2x times x, 2x squared. Minus 1 times minus 3 plus 3. Minus 1x minus 6x minus 7x. So x is equal to 1 over 2 or x is equal to 3. And your first one, x is equal to minus 1. And there we go. There are our 3 x-intercepts. So there we go, guys. Onliners and on-siters, take this down. Yes, where to? Where to in Glovo? X is equal to minus 1, x is equal to 3, or x is equal to a half. Absolutely correct. Danko. Well done, where to? Well done. Right, so we're done with, we got y-intercept, we got x-intercepts. What am I short of? Turning points, derivative. Turning points, derivative, point of inflection, second derivative. The derivative of the derivative. The gradient of the gradient. The turning point of the turning point. First derivative is turning point. Second derivative is the turning point of the turning point. Okay, so you got this down, right? You got this down. In fact, let's do this. Now that you've got that, it's f of x is equal to 2x cubed minus 5x squared. Let's write it. Let's open up f of x. Don't worry, I've still got it here. I haven't taken it away. Just opening up a new slide. Call it out for me. 2x cubed minus 5x squared minus 4x plus 3. Good. We now want our turning points. So we're going to say f dash x. Power rule, derivative. So 3 times 2 is 6. X, 3 minus 1 is 2. 2 times minus 5 minus 10x. 1 times minus 4 is minus 4. For minimum or maximum, derivative must always equal to 0. Yes or no? For minimum or for maximum. For minimum or for maximum, your derivative must always equal to 0. Divide by 2, I get 3x squared minus 5x minus 2 equals to 0. I'm dividing everything by 2. And what are our factors here? Now here, guys, we're going to have to factorize. Let's check. Does it factorize perfectly? So, any of you got your silver scientific calculator? Do I see it there? If we factorize this, you can cheat. Take your silver calculator with you in the exam to factorize. Some schools allow it, some schools don't. Let's bring it here. Give me a silver calculator. The silver one, it factorizes for you. The silver one factorizes for you. So let's go mode equation ax squared plus bx plus 3, negative 5, negative 2 equals. X is equal to 2. So here we go. X is equal to 2 or x is equal to, let's check, negative a third. So we got our 2 x values of our turning points. We now take this and we sub it back into original. So f of 2 to get my y value. Remember, my first x value is 2. My second x value is minus a third. We're short of our 2 y values. So what do? We sub it back into original. So let's see, what do we have? Mode comp. Let's go. 2 open brackets. 2 to the power. Okay, it looks like you don't have your buttons have all been wiped out. I don't know what you used on it,
Been
turpentine or
chowed. It's been chowed, Mr. Kota.
chowder buttons. There's no buttons left, bruh. There are no
There's
buttons
no
left.
sandwiches. No
Nothing.
sandwiches for lunchtime.
Some she had it for breakfast this morning. 2 open, 2 into power 3 minus 5 into 2 close bracket squared minus 4 into 2 close brackets plus 3. Boom, minus 9. Oh, now we're going to have f of minus a third. So let's go and put minus a third in. So let's go all the way back to our equation. Let's delete that. Fraction negative 1 over 3. Let's go back here. Delete fraction minus 1 over 3. Let's go to the side. Let's delete. Boom. Fraction minus 1 over 3. And that's it, huh? Bada bing, bada boom. 100 over 27. 3,7. 3,7 or 100 over 27. So here we go. 3,7. That's our 2 turning points. So let's go back here. We're done with the y-intercept. We're done with the x-intercept. We're done with the 2 turning points. What am I short of, guys? Point of inflection. So now we do POI, point of inflection, the last component, second derivative, f double dash x. So again, so now we need to find the derivative of the derivative. So 2 times 6 is 12x minus 10 equals 0. 12x equals 10. X equals 10 over 12. X is equal to 5 over 6. Take the 5 over 6 and put it back into original to get the y value of your point of inflection. So fraction 5 over 6. Let's go back, delete, fraction 5 over 6. Work with me, guys. This is your June exams, 5 over 6, 4. We've got everything in there, plus 3, boom. Minus 2,6. And there we go. There is all your calculations, or there are all your calculations. Make sure you do all your calculations correctly. You get marks for it. Right, now sketch the graph. For those of you who are done, who are sharp, you can already start going ahead. Start sketching the graph. Draw a rough sketch. Rough doesn't mean untidy. Rough means just not drawn to scale. So go ahead and draw the scale. And let's start answering all the theory questions after this. Please, you need to learn all this theory. Let's go, let's go, let's go, let's go, let's go, let's go, let's go. Let's sketch the graph. Guys, you guys can start. Let's check our onliners. Are they still wide awake and bright and fresh and early on a Sunday morning? Yes, Sibabatso. Y value negative 2,6. Absolutely. Rabia, second derivative is the derivative of the derivative. Tandeka and Tanda, if you can't see, we are moving at super high speed internet. So it might be that your internet connection at your area or in your location is down. Please check your internet connection or go out and come back in. Jay King, have you guys done this in school before? Have you done this in school before? Now, obviously, you might be a little bit lost if you haven't done it in school, but if you pay attention to what I'm doing, you will get it right. Let's draw the graph. You'll see everything come together. Jay King, our onliner, you'll see everything come together when we need to draw the graph. So let's sketch the graph. Let's sketch the graph. So there we go. That's my y-axis. That's my x-axis. Right. Guys, what is our y-intercept? 0 and 3. What are our turning points? What was our turning points? 2 and -9. -1/3 and 3,7. Am I right? That was our turning points. What were our x-intercepts? What were our x-intercepts? -1. -1, just go and check for me. What was our x-intercepts? Okay. -1, half, and 3. -1, a half, and 3. What was our point of inflection? Let's go back. 5/6 and -2,6. 5/6 and -2,6. Right. J. King, now you can see why we did all those calculations. Because we needed all of this. Right, Jay? Jay, are you still there? Online? Hit us up there in the comments. Let's see. Now you understand why we did all those. Yeah, don't worry. O'Neill, Malapa, you're struggling with optimization. It's going to be a walk in the park. You're going to love it when I do it with you next. Right, so let's go. X-intercepts. -1. There we go. Half. So that's 1. So half. There we go. -1 and 3. 1, 2, 3. There we go. There we go. I hope you guys are all following. Onliners, I hope you're all following. O'Neill, don't stress. I got you. You're going to love optimization when I do it next. Y-intercept 3. 1, 2, 3. That's your y-intercept. Your turning points 2 and -9. So you put a dotted line through your x. That's your first point. 2 and -9. -1/3 and 3,7. That's -1, -2, -3. So that would be a half. 1. So that's 1/3. -1/3. Put another dotted line there. Put another dotted line there. And that's -1/3. And what? 3,7. So 3,7 is somewhere there. So -1/3 and 3,7 is there. Right, now let's join the dots. It's a positive graph. Guys, our A value is greater than 0, so it's a positive graph. So it goes from the bottom up. It's got 3 x-intercepts. So here goes. Watch me. And listen to what I'm saying. Put your pens down. Increasing, 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 stationary. Decreasing, 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 stationary. Increasing, increasing, increasing to positive infinity. So they're going to ask you for which values of it is it increasing, for which value, and that's what we're going to get to now. So they're going to ask you increasing, decreasing, they're going to ask you concave up, concave down. Remember, increasing and decreasing, increasing or decreasing, talks about our turning points. Where is the graph increasing or decreasing? Turning points. Where is the graph concave up or concave down? Talks about our point of inflection. So 5/6. 5/6 and -2,6 is somewhere there. That's your point of inflection, POI. 5/6 and -2,6. Right, onliners? There we go. Your graph is fully sketched. Don't put it in here. You have to use your decimals because you can't plot fractions. You can plot decimals, but you can't plot fractions. All right. Here goes. Now, for which values of x? For which value or values of x is f of x increasing, decreasing? These are all exam questions. Concave up, concave down. Learn this. So where is it increasing? Increasing or decreasing talks about the x value of our turning point. So it's increasing, increasing, increasing here from negative infinity up to minus a third. That's where it's increasing. Or it's increasing here from 2 to positive infinity. That's where the graph is increasing. So for increasing, we look at the x value of our turning points. For decreasing, between the two. So it's between there. There's it. Decreasing, 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 decreasing. Between minus a third. So you can say x less than 2 but greater than minus a third. And you can say x is an element of real numbers. Or you can write it from minus a third up to 2, like that. You can write it like that, or you can write it in inequality form. Both are correct. One is interval notation, the other one is inequality. Your memo will give you maybe 1 or 2 or both. But no problem, whichever one you give, you're going to get the answer right. You guys following there at the back? We all good? Onliners, let's check our onliners. There we go. Now let's do concavity. Concave up, concave down. We look at the x value of our turning point. You can see it's concave down here. And you can see it's concave up there. Watch here. I'm going to do it in a different color. It's concave down up to that point. And it's concave up on that point. So where's it concave up? From 5/6 to positive infinity. And where is it concave down? From minus infinity up to 5/6. And there we go. Remember I said we look at the point of inflection. For concave up, concave down, we look at the x value of the point of inflection. Right. Some interesting questions that they can ask you here. They can ask you to sketch the derivative. Sketch, okay, the next question. Sketch the derivative and show the point of inflection. Sketch the derivative. The next one, the next question. Sketch the derivative. Watch here. The next question. Sketch the derivative. And indicate and show the point of inflection. Sketch the derivative and show the point of inflection. Absolutely. Sipesitle Vilakazi. Shelter Soko. Well done, you're following. Well done, Sitle. Well done, Aprila. Rabia Kesem. Bob what? The builder. Tapi Mesh. The point of inflection is supposed to lie. No. No. Good question there, Topi. No. The point of inflection does not have to lie on the graph. It's the point of acceleration. Watch here. Point of inflection means decelerating, 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 change over. That means the car is moving at a tremendous speed. Now he starts braking, 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 braking. He gets to this point and he starts accelerating. This in blue is acceleration. Very good question there. Very good question. Who was that? Tapi Mesh. Good question, boss. Very good. Right. Now watch. So we got increasing, decreasing. Let's sketch. Watch here how we sketch the derivative. The derivative, what was the derivative? The derivative was our turning points, am I right? Remember, listen, pay attention. What was our derivative? It was f dash x was equal to, what was it? 6x squared, call it out for me. Minus 10x minus 4. Minus 10x minus 4. My two x values here after factorizing were the two x values of my turning point. Was minus a third or 2. What was my point of inflection? 5/6 and minus 2,6. So let's sketch this graph. So all we do, that's a parabola. We're sketching the derivative. That's the one x value is minus a third. The other x value is 2. This is my point of inflection. The turning point of my derivative. That's my derivative graph. F dash. F dash is a parabola. F dash is a parabola. And the point of inflection here is 5/6 and minus 2,6. So there we go. There is concave down. Concave down. And from here going up is also concave up. So you can determine the point of where it's concave down or concave up either by looking at the original and the point of inflection or by sketching the derivative. And then from your turning point to positive infinity is concave up, and from negative infinity up to the turning point here is concave down. So let's give you one more question like this to prep you for your June exams. Not on sketching the entire graph. A very highly possible exam question, which I think, I got a hunch, might come out. I got a hunch that might come out. Watch here. For those of you who have taken this one down, relax. Auna stress.
Mr. K has got some inside intel about the
No,
June
nothing.
examination
It's
paper.
just a hunch. Maybe it's just a relationship with Mudimu. And Mudimu just put it in the head. So this is G dash X. They give me the two X intercepts here. They tell you that's minus 2 and they tell you that is 4. This is point D. That is point A. That is point B. Dx and Y. Right. Sketch is the derivative of G. Sketch is the derivative of G. G being the original. This is G dash, the parabola. Question number 1. I want the X values of the turning points of G. Where is graph G increasing? Values of X increasing, decreasing. Where is G? I want the value of values of X for which G of X, the original, is concave up, concave down. And the last question, find the derivative. I want the equation of the derivative. Find the derivative. Find G dash X. I want the equation of G dash X. So these are all 1 mark, 1 mark, 1 mark, 1 mark. The last one is 3 marks. Let's go. Try it on your own. Let's see how smart are you. Let's see how smart are you. Let's give you mark allocations here. The x values of the turning point, let's make that 2 marks. Increasing 2 marks. Decreasing 1 mark. Where is it concave? Up 1 mark. Where is it concave? Down 1 mark. The equation of G, 3 marks. How many marks on this? 2, 4, 5, 6, 7, and 3. Boom. 10 marks. Opticop. Opicopy. 10 marks for Mahala. Learn this. I beg you guys, onliners, on-siters, learn this question. Question, answers. Hasanain, how are we doing there, bro? While everybody is doing it there,
Just a reminder that we are doing Maths paper 2 today. There's some questions from learners. They're struggling with certain geometry
yes, definitely. We're ending
issues.
up with Euclidean today. Yes, definitely, see Claire. Euclidean geometry is the last topic for today. Yes, the derivative of a cube is 1 power less, which is always a parabola. 1 power less than a cube is a square, and a square is always a parabola. Yes, Josephine. I told you guys, relax, Josephine. Everything will fall into place. Everything will fall into place. Yesterday, you people were too overwhelmed. You were just getting used to me. It was your first day. We were just getting introduced to each other. Today, you're settling in nicely. Right, let's go. Let's go, let's go, let's go. Euclidean and paper 2 and trigonometry is all after break. We're finishing up the paper 1 from yesterday. Relax. Calm your farm. Hold your horses. Right, let's answer question number 1. The x values of the turning point. The x values of your turning point are our 2 x-intercepts of the derivative. Remember, the graph is going to look like this, guys. And that x value there is minus 2 taken from there. And that x value there is going to be 4. We don't have its y. We're not interested in its y. For which values? For which x values? So our x values of our turning points, to answer question number 1, x is equal to negative 2, or x is equal to 4. If they want the coordinates, then you'll say minus 2 and y, 4 and y. But they only want the x values of the turning points. So you just say minus 2 and 4. Taken from where? Minus 2 and 4. Taken from where? A and B here. Question number 2. Where is G, the original increasing? So it's increasing from negative infinity up to minus 2. So it's increasing from minus infinity up to 2 and from 4 to positive infinity. Where is it decreasing? Where is it decreasing, guys? Between, yes, it's decreasing there. So for x less than 4, here it's decreasing, decreasing, decreasing. X less than 4 but greater than minus 2. You can't put an equal to sign because it's stationary at that point. If you go and you put an equal to sign, you get 0. They'll mark it wrong. They'll just put a line through it. It means you don't know that the derivative at the stationary point is 0. It can't be increasing, can't be decreasing. It's stationary. Derivative is 0. Gradient is 0 at the turning points. Number 3, concave up. Concave up. Point of inflection. We need that point. So between 2 and 4 is how many units? Between 2 and 4 is 6 units. And we want the halfway mark. So 2 plus 4 is 6. Right? 6 divided by 2 is 1. So it's either 3 units that way or 3 units this way. So 4 minus 3 is how much? 1. So D's x value is 1 and y. Yes or no? The halfway point. The halfway point between the distance between your two x-intercepts, and we divide it by 2 because it's the midpoint. So 2 plus 4 is 6. 6 divided by 2 is 3. We move 3 units that way, or we move 3 units that way. So we land on 1. And there we go. D's x value is 1. So concave up is from 1. So you had to do this first. 1 to positive infinity. And where is it concave down? From negative infinity up to 1. And there we go. We've done question number 1, question number 2, question number 3. We now only left with the equation of g dash x. Find the derivative. They can either say the equation or they can say find the derivative. Two ways in which that last question can be asked, guys.
Handwriting, Mr. Kota.
Right. They can't see. A lot of them are blurring. They're blurring because of the internet connection. They're blurring because of the internet connection. They'll pick up the crystal clear on the recording if the internet is bad. Let's find the derivative. Let us find the derivative. We're answering question number 4. We are answering question number 4. Find the equation of g dash x or find the derivative. So we're going to go g dash x is equal to x minus x1 into x minus x2. Remember from functions? Remember from functions when you have to find the equation of a parabola? X minus x1 into x minus x2? That's it. So x minus minus 2 plus 2 into x minus 4. So g dash x is equal to x squared plus 2 minus 4 is minus 2x minus 8. And there we go. That is the derivative. The derivative is the parabola. So it's a functions question asked in calculus. Make sense? Good. Onliners, let's see. There we go. Rory-san, not visible enough. Check your internet. Thank you, Jacques. Go to your settings, check your quality. Thank you, O'Neill. Senelizwe. Yes, you will, Zuer. You will get this one. I've taken this type of question out of a past paper. In fact, out of a prelim paper before. So learn this. Watch the recording over and over and over. You can't simplify any further than that, Saeed. You can't simplify any further than that. So there we go. We're now going into how do we find the equation of a graph. Let's quickly go into that. It's 10 o'clock already. Let's find the equations of graphs. Now you might get, so you'll either get to sketch, you'll get sketching the derivative, or they'll give you the derivative graph, or they'll ask you to find the equation of the cubic function. So here goes. Let's do finding equations of the cubic graph. And then we do optimization, and that will take us to break. We come back from break. We start paper 2. Thank you all way too. It is easy. I don't know how you got a surname like Gupta. Right, here goes. The Guptas are busy in South Africa. Literally. Let's erase, let's erase, let's erase. Right, here goes. I'm clearing the frame. Shh. Take this one down. So now they give you a graph that looks like this. And they tell you that's -1, that is 3, and that is 6. They give you this point here as 2. They call this graph f. They tell you f of x is equal to x cubed plus 8x squared plus px plus q. Find APQ for 6 marks. So it either could be APQ or it could be ABC. Right. Pay attention. So we know, in fact, they're giving us another point. They're giving us another point. So in fact, wait here, guys. Let's change this. I'll tell you why. Because now we can't assume, because we got another point, we can't assume that the q is 2. Watch here. They tell you ax cubed plus bx squared plus px plus q. Find ABPQ. ABPQ for 6 months. There we go. We're making it even more interesting for you. We're giving you 3x intercepts and a point. Any other point. We gave you another point. 0 and 2. We could give you any point on the graph. 3x intercepts and a point. Please take this one down, guys. Take this one down. Follow how I do it. So in our answer, y equals a into x minus x1 into x minus x2 into x minus x3. That is your opening formula. What alphabet are we looking for? A. So that's x, that's y. That's x1, that's x2, that's x3. So whenever 3x intercepts and a point is given, that's the formula we commence with. What are we solving for? We're solving for A. Right, so what is x? What is y? Y is 2 equals a into x is 0 minus 1 plus 1 into 0 minus 3 into 0 minus 6. 2 equals a into 1 into minus 3 minus 6. 2 equals a times 1 is a into negative times negative is a positive. 6 times 3 is 18. A equals 2 over 18. A equals 1 over 9. So there we go. We got A. We have A. A is equal to 1 over 9. Are you all following? Can that be my final answer? No. I got to take this 1 over 9 and plug it back into here. So I'm just moving it here, guys. Watch here. I'm just moving it here because I need space. So now we're going to go. I'm going to do it here. Y equals 1 over 9. A into x plus 1 into x minus 3 into x minus 6. Now remove the brackets and collect your like terms. So f of x is equal to 1 over 9 into x plus 1 into, let's remove the brackets there, x squared minus 3 minus 6 minus 9x plus 18. Now we multiply out. First times all, second times all. So f of x is equal to 1 over 9 into x cubed minus 9x squared plus 18x plus 1x squared minus 9x plus 18. The moment of truth is coming up. 1 over 9 into x cubed. Let's collect like terms. Minus 9 plus 1 minus 8x squared. Plus 18 minus 9 plus 9x plus 18. Moment of truth, guys. We must get 2 as my y-intercept. That will test us whether we are right or wrong. So f of x is equal to 1 over 9. We got 1 over 9x cubed. Minus 8 over 9x squared plus 9 over 9 is 1x plus, boom, 18 divided by 9 is how much? 2. And what's our y-intercept? Do we think we're right or we know we're right? We know we're right. We don't think we're right. We know we're right because the y-intercept here, the y-intercept there is the same y-intercept on the graph. If you had to say let x equal to 0, that's your y-intercept. There's your y-intercept. You'll check whether it's the same. So we don't think we're right, we know we're right, guys. Learn this. Learn this. Yes, Chaya. So now we have when 3x intercepts at a point. What if the 2 turning points were given? What if the 2 turning points were given? Let's see how you guys do the next one. I want to see if you guys can do the next one on your own. So there are only 2 scenarios. Now pay attention before we do this. Thanks, Malukule Bengu. As long as you impressed and you're wowing us from that side, hit the like, hit the subscribe. Enjoy our YouTube channel. Enjoy our mathematics. Love it with us the way we have a passion for it. The quicker you love it, the quicker you'll ace it. The more you hate it, the more you'll fail. Love maths, guys, like we do here. Now, those of you who have taken this one out, now obviously now they can ask you questions on it, increasing, decreasing, concave up, concave down. I'm not going to do it. Watch here. Shh. Watch here. Here's another scenario. Here's another scenario. What if they gave you a graph that just went like that? They call that minus 2. And they call that x-intercept 3. And they call this graph G. And they say the following graph G of x is equal to x cubed, x, now they tell you minus x cubed plus ax squared plus bx plus c. Find a, b, c. It's a negative graph. It's a negative graph and it's bouncing on your x-axis. So this is the way we do it. This is the way we dala it. So y equals minus. There's the minus. It's a negative graph. into x minus x1 into x minus x2 into x minus x. Now, although, look, it's bouncing on the graph, so wherever it bounces, you use that x-intercept twice. Pay attention. Pay attention. So let's go. Let's do it together. Y equals minus into x plus 2 into x plus 2. We use it twice. Into x minus 3. So y equals minus into x minus 3 into x plus 2 squared. So it bounces. When it's squared, it means it's bouncing on your x-axis. So we use it twice. We use it twice. Please pay attention to this. Pay attention to this. This is very, very, very important. So y equals minus into x minus 3 into x squared plus 4x plus 4. So y equals minus into x cubed plus 4x squared plus 4x. So I'm done with x. Minus 3x squared minus 12x minus 12. So y equals minus into, collect like terms, x cubed plus 4 minus 3 plus x squared plus 4 minus 12 minus 8x minus 12. Your final answer g of x is equal to minus x cubed minus x squared plus 8x plus 12. Bada bing, bada boom. A is equal to minus 1. B is your coefficient of x, 8. C is equal to 12. That means that point there is 12. Yebo, yes. Where? Learn. Learn. I'm showing you all the different types. Plug me your CV. We need a maths teacher. You can afford me. You can afford. I'm lying. I'd love to teach you all, man. 10 rand a day. Nice, Mr. Gupta. That's Kotas Kambal. And no chips. Here we go. Here we go. Here we go. Here we go. Right, last one. Last one, I want you to do it. Well done, Muslim. Well done. Hey, Afan. It's coming up there. Afan Jan. Away. You feel like a genius. Not a genuine ass, but a genius. Be wise. Don't be otherwise. Otherwise, what? Otherwise. Otherwise what? Otherwise I'll slap you. I hate people that come and say, otherwise. Otherwise what, bro? Otherwise you're going to fail if you don't do K-way. Right, here goes, here goes, here goes. Otherwise, let's do this one. Otherwise, that is 2 and 20. Otherwise, that is 6 and minus 10. And otherwise, we leave it just like that. In fact, I give you that point there as 1. 0. Okay, let's make it. Okay, don't look like 1, right? That's 2. That's 1 and 3/4. Okay, you want me to make it look like 1? You want me to make it look like a 1? All right, wait, blob. Right, here goes. Okay, that's 1, right? 0 and 1. So otherwise, your your two turning points are given. They tell you this is graph f, and f of x is equal to x cubed plus ax squared plus bx plus q. Find APQ for 6 marks. We know Q is 1. What is Q? Where is it taken from? The y-intercept. So we already know Q is 1. This is the last one we are doing in the cubic graph. So in our answer, we know the Q is equal to your y-intercept, which is equal to 1. There we go, taken from there. Right, now our two turning points are given. Our two turning points are given. Let's see if you guys can do this one your own. Flux, you want to give me a packet of noodles? Indomie. 2 minutes. 2-minute noodles. I hope that's not your nickname. Let's do. Let's go. The two turning points are given. So f of x is equal to x cubed plus ax squared plus bx plus q. Right. I'm going to give you a beautiful template. So f dash x is equal to 3x squared plus 2ax plus b. For minimum or for maximum, f dash x must equal to 0. Yes or no? Now look here, pay attention. Cancel out the y. We're not interested in the y. We're only interested in the two x values. So we can call this SP1. We can call this SP2. Turning point 1, turning point 2. So SP1, watch here. Put down your pens. We're now going to plug the 2 for x. So 3 into 2 squared plus 2a into 2 plus p is equal to 0. Right? The q will fall away. The constant falls away. So 4 times 3 is 12 plus 4a plus b equals 0. So 4a plus b equals minus 12. Now we do SP2. I think you know where I'm going with this. Simultaneous equations. Now we're going 6. 3 into 6 squared plus 2a into 6 plus b equals 0. 36 times 3, 108 plus 12a plus b equals 0. 12a plus b equals minus 108. So we're going to have 12a plus b equals minus 108. Equation number 1. Equation number 2, I'm going to subtract the 2 to get rid of the p's. So 12 minus 4 is 8a, plus p minus p will cancel. Minus 108 plus 12 minus 96. So therefore a equals 96 over 8, 12, minus 12. And now we need P. We got 4a plus b is equal to minus 12. 4a plus b equals minus 12. 4 into minus 12 plus b equals minus 12. Minus 48 plus b equals minus 12. So p is equal to minus 12 plus 48, 36. So we got A. A equals minus 12. P equals 36. And Q is equal to 1. And there we go, guys. You answer this exactly the way we answered it here on the screen. That's a template when two turning points are given. We use the derivative and then put in our two x values into our derivative in order to find the equation of the graph. I hope you're taking this down. We're now going into volume and total surface area. Some of you onliners are there for the jolly good ride, just to chat on the comment section. Leave the comment section alone. You got something positive to say, that's what you put in. This session today is only for those of you who are serious about getting a distinction in math. Some of you are not serious. Some of you don't care about your future. Some of you, doesn't matter what you do, whether I master it or I don't master it, you'll remember my words in your exam. Your June exams are 3 weeks away. For some of you, 2 weeks away. Some of you are starting on the 1st of June. That's 9 days away. That's less than 2 weeks. Imagine. Now imagine you don't know this and you go into the exam. Mudir. Yes, LeBron. You starting next week, bro. 3 weeks. Let's go, let's go, let's go, let's go. I hope you guys have taken this down. Learn. I beg you, learn. Every template I give you, every example I do with you, master the system. Okay. In fact, if I was given the opportunity by the president or by the Department of Education, I swear, I teach you the whole year's work in 2 weeks flat, beginning of the year. After that, we only work with past papers till the end of the year. Would be nice, ne? Would be nice. Teach the whole country, the whole year's syllabus in 2 weeks. After that, every Saturday you come in, we just crack past papers, Sakai papers, IEB papers, DOE papers. Yes, yes. By June, you'll be dreaming, you'll be talking math, you'll be breathing maths. Kway students already who have been with me from the beginning of the year, they're already dreaming maths. We got learners here sitting at the back who are already in their 90s. Pick up your hand there. Pick up your hand. There we go. There's my 90s. There's my 90s. He knows. He's looking at all of this. He's not even writing. This is all just revision. And he's not even from South Africa. He's from Libya. Give him a nice round of applause, guys. Well done. That's my boys. That's my boys. My 90s. They know. They are aiming for 95 plus. There's nothing. They know I'm not going to accept anything less than 95. They know. They know. Hasanain, I've already earmarked my 95ers, my 99ers. Let's see if my onliners and on-siters actually surprise us in the exam.
Another Rory song in the making, Mr. Kota.
This is still from Libya, bruh. This is still from Libya. This is not even from South Africa.
Africa Unite.
You know most. You know most. Let's dala. Right, we're doing the last topic in calculus optimization. I'm showing you calculus application in real life. Now, I know for many of you, listen to me. You know total surface area. You've got many different formulas for different shapes, am I right? How about I give you one formula you can use for all shapes? Right, watch here. Total surface area. Right. TSA. For all standard shapes. What do I mean standard shapes? And this is for closed, top, and bottom. Closed, top, and bottom. Meaning that if I had a box, so say I had a box, and the bottom is closed and the top is closed. So whether it's a box, whether it's a cube, whether it's a cylinder, or whether it's a triangular prism like a Toblerone chocolate box. These are what we call our standard shapes. Because top and bottom is closed, I say 2 times area of base plus perimeter, PER, perimeter of base times your height. So basically we can shorten this also, 2AB plus perimeter of base times your height. So total surface area for closed top and bottom is 2AB plus PBH. Don't forget this. We're going to be using it. In fact, somebody sent me a question last night. We're going to do that question now. 2AB plus PBH, 2 times area of base. So if your base is a rectangle, would be length times breadth. Your perimeter would be side, 2 times side plus 2 times side. You'll just adapt it for the different shapes. If it's a cubed, area of base, length times breadth. Perimeter of base, 4 times side. If it's a cylinder, area of base is pi r squared. The perimeter of the base would be 2 pi r. That's the circumference. If it's a triangle, area of base would be half base times perpendicular height. Perimeter of your base would be side plus side plus side. So what is total surface area, guys? 2AB plus PBH. Yes or no? Don't forget this. But that's for closed top and bottom. That is for closed top and bottom. What if it's a drinking glass? What if it's a drinking glass? And the bottom is closed and the top is open, then total surface area is equal to 1 times area of base, because there's only one base, plus perimeter of base times height. And if it was like a toilet roll holder, and both sides were open, total surface area is equal to, are there any bases here? No. So you won't, so this is now one base. Then you'll say 1 times area of base, and then no base. You'll just say perimeter of base times height, because there's no bases. So you just adapt this formula. So total surface area is 2AB plus PBH for closed top. So if the box is closed on the top and closed at the bottom. Take this formula down, remember it for your exams. You will shine too one day divinely. You will have to shine in the June exams. You will shine in the prelims, and you will be kiwi shine, gloss shine in your final exam. Listen to what I say, follow what I tell you, you won't go wrong. Right, let's go. I'm clearing the frame. You got this 2AB plus PBH. Here goes. In fact, let's start off with this. Now, when we talk about optimization or calculus application in real life, we talk about 3 components. So they might give you an exam, volume and total surface area. These are the type of questions you will get. Type of questions. You will either get a volume and total surface area. And how will that look? Show that the total surface area is equal to blah, 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 blah. Find x giving maximum or minimum area. Find x giving minimum or maximum area. And then find the maximum area. The second optimization, and you'll only get one. You'll only be examined on one of the three. So this is number one. Number two, you might get a graph. And you might get something like that, and you might get a box there, and they'll give you that. So you'll get it in terms of, so the first one you'll get it in volume and total surface area. The second one in terms of graphs. Optimization in terms of graphs. The third one in terms of speed, velocity, acceleration. And each one of them, 3 marks, 3 marks, 3 marks, total marks 9. So it will all be 9 plus minus 10 marks. Plus minus 10 marks. Optimization in your exams is only 10 marks. It's the last question of your calculus. So the first question is first principles. Derivative, differentiation, equations of tangents, the cubic graph, and then optimization for 10 marks. This year wraps up the whole of optimization. So now that you've got this down, in fact, we'll continue after break. I think it's time for break. In fact, before break, let's just do one in terms of total surface area. We'll come back, we'll finish the other two, and we'll start with paper 2. In fact, I'll start with trigs, compound and double angles first, because the analytics is easy. So let's, after break, we'll start. So in fact, guys, take this down. Take this down. Take this down. Let's do one in terms of volume or total surface area. So the one that Sipo sent me last night, Sipo is from KZN. So let's see what is Sipo's question.
Is Sipo a real person, Mr. K?
Yes. Sipo Mapumulo.
Okay.
So here goes Sipo. Let's go. He asked me a question, and here we go. I got him on my WhatsApp as well. So Sipo sent me a question. A rectangular box has a length. So let's do this one for Sipo and for everybody. So let's go. So they give you let's draw the box. Let's draw the box. Right, they tell us it's got a length of 5x. It's got a breadth of 9 minus 2x. And it's got a height of x. This one came out of a past paper. Show that the volume, here we go, show that the volume of the box is given by V equals 45x squared. I know you're all hungry. And I know you're dying for your breakfast. We're going to go now. Find x giving maximum volume. Remember I told you whenever they ask for minimum or maximum, what must we do? Derivative. Remember, minimum or maximum derivative equals 0. Find the maximum volume. Question number 4. Find the total surface area of the box. And it's a closed box. Find the total surface area of the box. Find the total surface area. Now they want the exact total surface area. They don't want just in terms of x. So let's put your mark allocation. 3 marks, 3 marks, 3 marks, 9 marks. Because when they want, it means you first got to do all three parts. You got to find the total surface area in terms of x, find x giving maximum total surface area, and then find the total surface area. That's why it's 9 marks. 9 and 3 is 12 and 3 is 15. Total marks 18 marks. So let's answer question number 1. Okay, do you guys want to give it a go on your own? Come on, volume. What do you know? Volume of a box is length times breadth times height. So do it, guys. Do it. Come, I'll give you 5 minutes. I'll give you 5 minutes and let's see if you can answer all 4 questions for 18 marks and score full marks. Kway students, crack it. You know what to do. Let's see within 5 minutes, can you get all 18 marks? Here's a little bit of a challenge for you. Come, Mansur, Abdul Rahman. Crack it. Go for it. Onliners, let's see how sharp are you. Go for it. Go for it. Go for it. Thanks, Uwetu. Good lesson. Good to have you online. Crack it. I'm just taking 2 minutes to stretch. I'll come back. We mark. We go for break. What I call stretch. 2 minutes, guys. 2 minutes. Hasanain, you can keep them. Are you there, Hasanain?
Sir, I can sing. I can sing for them. What you want me to do? I can jump through hoops.
Let's check if the speakers can withstand your voice, bro.
Okay, no problem.
Crack it.
Mr. Kauta,
Gee.
number 1 or number 2? Where are you going?
How can you ask me that? I'm just going to stretch, bruh.
Okay.
I need some oxygen.
Okay.
Dot.
Okay. That's Mr. Kota. You'll be joining us shortly, but you can have a crack at that problem. And then after the break, we will be resuming with what we set out today, and that is Maths Paper 2, geometry and the like. Mr. Kota will be going through Euclidean, and the list goes on. So you'll be tackling that today. So this is day 2 of the grade 12 maths workshop, where we focus on Maths Paper 2. Don't forget to subscribe to the YouTube channel. We've got some more workshops lined up during the course of the year to prepare you for your prelim as well as your final examination. So just another a problem to crack, and then we will be heading off to lunch, to a break time. Don't forget to send us a few photos. If you are at a school and you're logging on at your school, send us a few photos. If you're an educator, send us some photos in your living room. If you are with some of your fellow classmates, if you're linking up at home from your mobile phone, send us a few pics and we will put that up at the end of the session. Keep those comments and keep the energy coming. You've been an amazing audience. So that's what the program looks like. I think Mr. Kauto will be handling the analytics. He will be doing analytics. So yes, Fasiha, we will be handling analytics after the break.
Let's crack it. Let's give you the memo.
Looks like Mr. Kota is back into the building, so we will be resuming now with the solution to this answer.
We are back. We are back. We are back. Let's go.
Did you
Let's
wash
go.
your-
Let's go.
Did you wash your hands, Mr. Kota?
Properly. And my
Okay.
throat.
Take it away. Take it away.
Let's go. Let's go. Let's go. Let's go. Show that volume. So we're answering question number 1. Volume, length times breadth times height. So length is 5x. My breadth is 9 minus 2x. And my height is x. So now bring this x to the front. 5x times x is 5x squared. This is just algebra. You don't know algebra, you're going to fail. That times that is 45x squared minus 10x cubed. Isn't that what they asked me to do? Yeah, boy. So we did what they asked. 1 mark, 2 marks, 3 marks. Question number 2. Simple like a pumple. Simple like a pumple. Just don't burst it. Find x giving maximum volume. dv over dx. Derivative is equal to power rule 2 times 45. 90x minus 3 times 10 is what? 30x squared. Derivative is equal to 0 for minimum or maximum. For minimum or maximum, your derivative is always equal to 0. So let's write it. For minimum or for maximum, your derivative is always equal to 0. Let's take out our HCF. We're solving for x because that's what they asked. Find x giving maximum volume. So let's take out 30x as my highest common factor. I'm left with 90 divided by 30 is 3. X and x will cancel. Minus 30 and 30 will cancel. X squared over x is equal to 0. So 30x equals 0. Or 3 minus x equal to 0. X is equal to 0 over 30 is 0. Or minus x equal minus 3. X is equal to 3. Now, which one do you think? Is it 0 or x giving maximum? Is it 0 or 3? We don't know yet. If I put in 0 in here, I'm going to get 0. So it can't be 0. So it has to be 3. Sometimes when you put in the higher one, it gives you a negative volume. Can you ever get a negative volume of a shape? No. So sometimes the lower one gives you maximum. Be careful. You'll have to check each one separately. In this case, therefore, 3 is x, giving minimum or maximum, giving maximum volume. Question number 3. Find the maximum volume. So volume is equal to 45x squared minus 10x cubed. We found 3 is x. So 45 into 3 squared minus 10 into 3 cubed. Ooh, what happens here? Okay, let's see. 3 squared is 9. 9 times 45. 9 times 45 is 405. Minus 3 cubed is 27 times 10 is 270. 405 minus 270. Boom, we get a positive answer, 135 units cubed. And that is the volume. And there we go, we've answered the first 3. We're now going to just do the total surface area for 9 marks, and then we go for break. I know you guys are tired. I know we're going a little bit over time. But you know what? It's necessary. And you grade 12s, you are not kids now. You are adults. You are not learners. You are students. And students have got resilience. And students have got grit. And students have got passion and drive. You are not learners. You are students. You are candidates. You are the future of our country. Imagine your ship is sailing and you say, hey, I think it's lunchtime. Ew. And that is exactly what is happening to our country. Everybody's on lunch. Everybody's on break. Except us. We work around the clock. When the brain says shut down, what do we say? Shut up. Love you guys lots. I hope you guys all do well. From the bottom of our hearts, we share the care from Awqaf and from Kway. We hope that you guys all, teachers, learners, I hope you guys are benefiting. I hope you are loving math. I hope you got a passion, you got a drive to get your distinction. And when your maths comes right, your science will come right, your English comes right, every other topic comes right.
Got some positive comments coming in there, Mr. Kota. Thank you for that positive affirmation.
Let's see where you guys are. We love you. We love you. We love you. Come, guys. Come, guys. Can you share that you can Google, guys? Pass your papers. There is enough on the internet. Go on to NSC Pass Papers. Go on to IEB. Speak to your teachers. There's enough resource material available for you. But once you master our Kway and Awqaf methods, you will fly through your past papers like a hot knife through butter.
That sounds like a very mock commercial there, Mr. Kota there, giving you
That's why
idea.
total surface area, they're all hungry. What do you say for hungry in Zulu or Sotho? Lapile. 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 Right, total surface area. Total surface area is 2AB plus PBH. Now this is all integrated in one question. So now 2 times area of base. So it's 5x into 9 minus 2x, area of base, plus, now it gets a bit rough. Perimeter of base. Remember the diagram looks like that. So it's 2 times the one side. So 2, remember, it's side plus side plus side plus side. So you can say 2 times 5x plus 2 times 9 minus 2x times your height, which is x. There we go. Learn this. I beg you onliners, pay attention to what I'm doing. This is straight out of a past paper. You cannot afford not to pay attention today. You'll see when I do compound and double angles next, after break. So 2 times 5x is 10x. 9 minus 2x. Plus 2 times 5x is 10x. Plus 2 times 9 is 18. Minus 4x. Don't mess up your algebra. I don't have a memo for this. I'm working with you as if we are writing our June exam. 10x times 9 is 90x. Minus 2 times 10 is 20x squared. Plus, let's bring the x in the front. 10 minus 4 is what? 6x plus 18. No memo, guys. We're working without a memo here. So that is 90x minus 20x squared plus 6x squared plus 18x. That is equal to minus 20 plus 6 is minus 14x squared plus 90x. No, 90 plus 18 is 108x. And there we go. That's your total surface area in term units squared. That's your total surface area in terms of x. Find the total surface area. That means we still need to find the derivative. Therefore, dA over dx is minus 28x plus 108 equal to 0. We're not yet done. We first need to find x, then take x and put it back into the original. So don't stop here. I'm moving over to the side. Minus 28x is equal to minus 108. X is equal to 108 divided by 28. 3,857, 3,9. Now take the 3,9 and put it back into this. Because we found x. Now we put x. Here's your final answer. Let's do it here on the side. Your final answer is your total surface area is equal to minus 14 into 3,9 squared plus 108 into 3,9. Here's your final answer coming up. Now you get 9 marks. Let's go. Minus 14 into 3,9 squared plus 108 into 3,9. And let's pray to God we get a positive answer. Yay! 208,26. 208,26 units squared. You must put unit squared. They will minus the mark because they're asking you for area. Don't just go put 208,26. Don't give them a reason to minus a mark from you. I hope you guys enjoyed the session. I hope you learned a lot. Now you see calculus in real life. We did first principles, derivative, differentiation, equation of tangents. We did the cubic graph. We did sketching. We did point of inflection. We did optimization. Boys and girls, give yourselves a nice round of applause. It's 10:53. I think at 11:30. Hasanain, let's give them till 11:30. 11:30 we will resume. Enjoy your break, enjoy your break, enjoy your break. You're getting smarter, Camel. Well done. Offense, 208,26 is the answer. Well done. Got it right divinely. What a guy. Getting smarter, Camel Bradley. Hit us up. Which area of South Africa are you coming from? Where you guys?
Mr. Kota, are you going to rest your vocal cords? You're going to get a little leg stretch. So Mr. Kota will be starting with
So
maths paper 2.
we both in yellow today, Hasanain. Yellow is the color of today, bro.
Okay, so Mr. Kota, you will resume with maths paper 2 after the break.
After break. Enjoy your break. Enjoy your break. Enjoy your break.
Okay, there we go. That was Mr. Kota. He's been taking the grade 12s through the session this morning. And please, we really appreciate your feedback and your comments. Send us a few photos of you connecting to the session. If you are an educator, if you've got some learners at your school, do send us a few photos. We'll definitely flight that on the session. We'd really love for you to send in some of your feedback, what you think of the session. You can send that, and my email address is on screen at the moment. And we're having great fun here with you today. And please also do not forget to post some photos to our Facebook, Instagram, as well as our Twitter account. Let's put up some of our socials on the screen, and you can use the hashtag Awqaf SA Maths, hashtag Awqaf SA. When you are doing your TikTok videos and some of your social media posting, we're on Facebook, we're on Instagram, on Twitter. Please do subscribe to our YouTube channel. That's Awqaf South Africa. Like and subscribe to the channel. We will be hosting more workshops to assist you for your preparation for the examination. And just to let you know, if you have any other siblings, we will be conducting a session, I think it's next week. and that session will be on grade 12 maths. So don't miss out on that. So we'll see you after the break. Please do keep those comments coming. Thank you so much.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care. Quality education is a cornerstone of a thriving and prosperous society. However, the South African educational system is under strain, necessitating the work of the Educational Waqf Fund to help ease the pressure. Our Matric Mathematics Upgrade project alone has already impacted the lives of over 40,000 matriculants. At the schools participating in our program, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience.
So I've never reached that kind of height before. It was quite a milestone, and I believe that Awqaf has been quite instrumental in me reaching that milestone. And I also liked the spirit. Mr. Kota made sure that we're always engaged with the content. So for me, that's what made it a very positive.
With the very first word of the Holy Quran being revealed as read, educating our community is an act of faith. With your help, we can transform many more lives.
Hello there, my name is Sororisa Makaila. I am in my first year of my undergraduate studies in actuarial science at the University of Cape Town. And as a result of hard work, dedication, support from friends, family, and teachers, and Awqaf's commitment to ensuring quality education for South Africans, I was able to obtain 100% in my matric examination for mathematics in 2022. So this was a culmination of very hard work that has been put in by myself and my teachers from earlier grades, more especially grade 11. I mean, this is a crucial part of your schooling career because universities offer provisional and conditional acceptances based on grade 11 results. And it's very heartbreaking to be willing to work hard towards your dreams in matric and not having anything to show for that with your grade 11 results. So it's very crucial that you work hard. And Awqaf SA has been greatly instrumental in me reaching my goals in matric. I believe that you can derive great value in attending the Awqaf SA mathematics workshops. I have gotten a lot of help from them and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like to thank Awqaf SA for their commitment in essentially building a better South Africa, because we know that in future careers that will be in great demand are those that involve science and mathematics, and by attending these workshops you'll be able to ensure that you participate in the future economy by working in these industries. So thank you very much to Awqaf SA and good luck on your examinations.
So welcome back. Hope you've had a nice break, stretch your legs, had something to eat, and we'll now resume with Maths Paper 1 with Mr. Kota. That was an address from Rory Sang. He attended the grade 12 maths workshop last year, and he achieved 100% in his final maths result last year. So with that, let's call on Mr. Kota. You have to unmute your mic, Mr. Kota.
Unmute ourselves. We're back. And thank you for all the comments. Hope you guys enjoyed a little bit of a comfort break. You got some hydration, all good vibes, innocent. Worspool, Rudaput, Mbongwe coming in, Larato. And Sape says a very powerful, informative presentation. Thank you so much. Bokomaso SS Tembisa. Peace. Big shout out to you. And big shout out to everybody else who's been part of this initiative. And thank you, Awqaf, hasanain, Danko, to my co-pilot, Said Farah, enjoying the lesson. We're now into Trig's paper 2. Lebron. Kamo says she's getting smarter and she's getting brighter. As bright as our yellow colors here. Myself and hasanain, that was pure coordination. Right, guys, we're going into Trigs. I know the big component. I'm clearing here. Let's get started. Take out your books. Take out your scientific calculators. What do you need to know for Trigs? So here is your checklist. What do you need to know for Trigs? Number 1, you need to know reduction. Okay, the one screen is not up. Where's our IT backend guys? Ibrahim, to make sure that our one screen, our one projector here. Let's see, where's our guy? All right, can you guys see on that one for now until the other one comes up? Okay, good. Number 2, identities. Number 3, so reduction, we need to simplify. These are our same topics from last year. Only thing that will be included will be your compound and double angles. Identities would be to prove. Then we need to know how to use a diagram. Right? The Cartesian plane. Trig substitution. There we go. Thank you so much. IT is on the ball. Then we've got our non-90-degree triangle. Oh, wait. Before we go into non-90, solve for x, general solution. General solution. Then what do we have? Non-90-degree triangles. The area rule. The sine rule, the cos rule. That's your checklist. Take down your checklist. Let's go, Missouri land. Missouri, that's Eldorado Park, if I'm not mistaken. Lutendo, Matumba. That Missouri, I think Missouri, I used to do programs there. Missouri land, Eldorado Park. Aldos in the house. Let's go. Let's go. So take this down. Now, before we do this, let me teach you the rules of this game. Pay attention. We're going straight into past paper questions. I'm taking out from a host of past paper questions. Right, guys? If you guys got something positive to say, then put it up in the comment section. Stop communicating with other learners in the chat box on the side. Don't waste your time. Today is a big day. Let's get cracking, guys. Let's get cracking. Hasanain, how are we doing there on that side? We only good there? Londiwe Chizo. I think
We are on fire.
We are on fire. Don't stress. If your internet connection, you'll see how clear our internet and signal is when it goes up onto YouTube. So you'll know that our internet from our side, we are moving on super high. We are moving at lightning speed. Speed of light. So I'm clearing, that is what we're going to be doing. Now, let's start off with the compound angle. The compound angle, sine A plus B. So whenever you see an angle being added or subtracted, it's called compound. And the way we break up sine of a compound angle, sine cos, cos sine, and S for sine, S for the sine stays the same. So for sine, the sine stays the same. S, 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 S. So the sine stays. Then you put it AB, AB. So guys, what is sine of a compound angle? Sine, how would you write it out? Sine cos, cos sine, and the sine stays the same. How do we do it? Let's all say it together. Sine cos, cos sine, the sine stays the same. Say it again after me. Very good. Say it again. Sine of a compound angle. Excellent. So even if it was sine A minus B, what would it be? Sine, let's do it together. Sine cos, cos sine, and the sine stays the same. We put AB, AB. And if that's negative there, then this here will be negative here. So sine of a compound angle, sine cos, cos sine, the sine stays the same. Cos of a compound angle. This is cos cos, sine sine. And C for cos, C for change. Now it will become AB, AB. So sine of a compound angle is sine cos, cos sine, the sine stays the same. Cos of a compound angle, let's all say together, cos cos, sine sine, and the sign changes. So what is cos of a compound angle? Say it all. Cos cos. Very good. Cos of a compound angle. Sine of a compound angle. Very good, very good. Let's do it again. Sine of a compound angle. Cos of a compound angle. Yay, you know your compound angles. Now you don't need to follow. You don't need your formula sheet. Right, you'll see. Now it's very important that I do this for you because every question that I'm going to do is going to include this in it. Right, pay attention. So that was the compound angle, sine compound. So even if it was cos A minus B, that would be cos cos, sine sine, AB, AB, and the sign changes, the middle sign. Last time, sine of a compound angle, sine cos, cos sine, the sign stays the same. Cos of a compound angle, cos cos, sine sine, sign changes. You'll use this even those of you who are going to do, going into university and going to do maths next year. Well, you will be using it next year too. Right. That is the compound angle. Now we have the double angle. Very important. Very, 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 very important. The double angle. Now double means 2 times an angle. So we get sine 2 times an angle, or we get cos 2 times an angle. Right, let's go guys. Let's go, let's go, let's go, let's go, let's go, let's go. Right, sine 2a can only be broken up in one way. 2 sine A cos A. That's all. Nothing else. Now pay attention here. Sometimes you're going to get a catch in your exam. Watch this catch. Sometimes they tell you sine 4a. So that is sine, we make it a double angle, 2 times 2a. So this is equal to 2 sine, what's your angle? 2a, cos 2a. Learn. So sine 2a can only be broken up in one way, 2 sine a cos a. So sine 4a is sine 2, that's your double angle, 2 times 2a to give me 4a. And that's 2 sine 2a cos 2a. And if it was sine 6a, it would be 2 times 3a, which is 2 sine 3a cos 3a. So be careful. So sine 2a can only be broken up in one way. But cos 2a can be broken up by now, you know, in how many ways? 3 ways. Your first way, cos squared a minus sine squared a. Or if you want it only in terms of cos, 2 cos squared a minus 1. Or if you only want it in terms of sine, 1 minus 2 sine squared a. So take this down, very important, we're going to be applying this. So even if it was cos 4a, I'm just going to do it here on the side. You've all taken this on the left. So even if it was cos 4a here, this is equal to cos 2 times 2a. And now you can say 2 cos squared 2a minus 1. Or cos squared 2a minus sine squared 2a. Or 1 minus 2 sine squared 2a. So be careful. Be careful in your exams. For cos the sine, not the sine sin, sign, tabello. For cos, the sign in the middle changes. The sign, sign, not sine. Just responding to tabello there. It's the sign changes, not the sign changes. For cos. Right. I hope that answers. Please don't make mistakes. Don't make stupid mistakes in the exam. Right. So here we go. Sine of a compound angle. Sine cos, cos sine. The sine stays the same. Cos of a compound angle. Cos cos. Sine sine. Sine changes. Sine 2a can only be broken up in one way. 2 sine a cos a. But cos 2a can be broken up in 3 ways. Cos squared a minus sine squared a, 2 cos squared a minus 1, or 1 minus 2 sine squared a. We all got that? Let's go. Here's your first question from a past paper. I'll even tell you which past paper this one is coming out from. I'll tell you now. Department of Basic Education, June 2018. This is the National Common Paper, June 2018. Simplify to a single term. So they tell us to simplify. It means use your rules of reduction and use your compound or double angle rules. So cos x minus 360 into sine 90 plus x plus cos squared minus x minus 1. And it's worth 4 marks. Now this is pure reduction. This is pure reduction. Let's all do it together. Let's all do it together. Now watch here. This is the way I do. This is what we call the anti-clockwise angle. So what we do, you can just do that. Watch here. Watch here. Put your pens down. I'm showing you a different way. I'm showing you. So cos. Cos is in which quadrant? 4th quadrant. We're going 360 degrees anti-clockwise. So watch. From there to there is 90. From there to there is 180. From there to there is 270. We come all the way back. So cos 360. You know 180 and 360, the name stays the same, cos x. And what is cos? What is the original in this quadrant? Positive or negative? Positive. There we go. Remember, ASTC. All students take Coke. Right. All positive, sine positive, tan positive, cos positive. So that's how we do that. We start off with cos. We go 300, and if it was 180, it would have stopped here. And we would have asked ourselves, cos in this quadrant here would have been negative. But it's 360. So we go right around. Right, times. So we're done with the first one. Sine 90. 90 and 270. 90 and 270. What happens with 90 and 270? The name changes. From sine 90, it will become cos x. 90 plus. 90 plus is in my second quadrant. Look at the original. Sine in the second quadrant is positive. Cos squared of a negative angle. Even if it was cos of a negative angle, it would have been positive cos x. Cos of a negative angle changes to positive. So cos squared x would become plus cos squared x minus 1. Cos x times cos x, cos squared x plus cos squared x minus 1. Cos squared plus cos squared, 2 cos squared x minus 1. And to a single term, isn't that my double angle? Isn't that my double angle for cos? Yes or no? So this is cos 2x. And there we go, you get yourself 4 marks for that. Learn. We're going to do a whole lot of exam questions now. June exam, prelim exam, and final exam questions. Please, guys, if you need to repeat this, all students take cocaine. No, not all beware. Why did I use x instead of 360? 360 is the revolution. We're going 360 degrees anti-clockwise. Our angle is x. Our angle is not 360. So it's cos x, not cos 360. That's how many degrees it must go anti-clockwise. Remember, your quadrant falls away. Why are we reducing? To get rid of the quadrants, not to keep the quadrants. What happened to the 90? It fell away because we changed it to cos x. I hope that answers your question. Let's get high on crystal mathematics. It doesn't become minus cos. It doesn't become minus cos because cos is positive in the fourth quadrant. Cos is positive here. Cos is not negative, so it doesn't become minus. We're starting here, we're going 360 degrees anti-clockwise. And we land up back in the fourth quadrant. Cos in my fourth quadrant is positive. And here, cos of a negative angle is positive. Sine of a negative is negative. Tan of a negative is negative. Cos of a negative is positive. Cos of a negative angle is positive, and anything squared is positive. I hope that answers your question. Onliners. Let's go. Let's go. I hope you took it down. All right, for those of you who took that one down from the same paper, watch the next question. Write as a single trig ratio sine 2x plus 40. Take this down, guys. Cos x plus 30 minus cos 2x plus 40 times sine x plus 30 simplify. Question, answer. Let's do it together. Please, guys, I want you to take a breath before you do every trig question. Just stop. Take a deep breath. And tell yourself that if you're going to expand this, it's going to become so big that you know you're wrong. So what other method can we use? Watch here. 2x plus 40, 2x plus 40, x plus 30, x plus 30. It means our angles are identical, am I right? And look what we have. Sine, cos, cos, sine. So sine, cos, sine is my sine compound angle. So it's 2x plus 40 and the sine stays the same, minus x plus 30 in brackets. That's my compound angle for sine. Oh. There we go. Sine, cos, sine is your sine compound angle. It's that angle minus that angle. So that's sine 2x plus 40 minus x minus 30. That is equal to sine 2x minus 1x is x. 40 minus 30 is 10. And that's your final answer. Write as a single trig term in its simplest form. Now you know what's the next question. Hence find the general solution. Wait, this is quite. This one was worth 4 marks. The next question is worth 7 marks. 11 marks on these 2 questions. Hence find a general solution for sine 2x plus 40 cos x plus 30 minus cos 2x plus 40 sine x plus 30. Watch, very important. Is equal to cos 2x minus 20. Is equal to cos 2x minus 20 for 7 or 8 marks. Hence find the general solution. So hence means use the answer from the first to answer the second. Right. Now we found that this whole thing on the left hand side, we found that that is that. And this is that. So all we're going to do now, I'm erasing here, I'm answering question number 2. So watch what we do. So to answer question number 2, I'm going to say therefore sine x plus 10, which is this whole thing. So I scratch it out. This whole thing is x plus 10, sine x plus 10, is equal to cos 2x minus 20. There we go. That's where we start. That is where we start. Onliners, are you following? Rabia, how can it be wrong? We kept the sign. And then we multiplied that inside. Right, let's go. Let's erase. Now what do we do here? How do we find the general solution? And this is a very good question. Many of you don't know how to do that. So here's your answer. Your answer starts here. Watch what I do. Watch what I do. Onliners, put your pens down. Put your pens down and watch. You change the cos to sine. So watch here. Sine x plus 10 is equal to sine 90 minus 2x minus 20. Why? Sine 90 will change it to cos. Yes or no? Right, put your pens down. That's what you do. Step number 1. Step number 1. You change the cos to sine. Now watch. Put your pens down. If you didn't know how to do it, you need to follow. The sine and the sine cancels out. And it's sine. So we need to give 2 general solutions. One for quadrant 1 and one for quadrant 2. Quadrant 1 is 0 degrees plus. Quadrant 2 is 180 minus. Yes or no? So let's do it together. Watch here. You can do this in pencil on the side. So here goes. Quadrant 1. Guys, even onliners, follow the way we do it. X plus 10 is equal to, so we cancel that, we cancel that. 0 plus, so we don't need to put 0 plus in. So it's just 90 minus 2x minus 20 plus k times 360, where k is an element of integers. Your general solution for sine. Your second general solution, x plus 10, pay attention, is equal to 180 minus. There's quadrant 2. Now you put it in brackets. 90 minus 2x minus 20 plus k times 360 or 360k, where k is an element of integers. Now we solve for x. Now we solve for x. Guys, are you following? Thank you, Flonipa. Wake up. This is important. Thank you, Kemo. You guys are following. Thank you, Apiwe. Thank you, Akila. Onliners. Now let's solve. I'm going to work a bit fast now because this is the algebra. So let's all do it together. Right. X plus 10 is equal to 90 minus 2x plus 20 plus k times 360, where k is an element of integers. So x plus 2x, 3x. 90 plus 20 is 110 minus 10 is 100. 90 plus 20 is 110. 110 minus 10 is 100 plus k times 360, where k is an element of integers. X is equal to 100 divided by 3 is 33,3. So 33,3 plus k times, you divide that also by 3, 120, where k is an element of integers. That's your first solution. That is your first solution. That's why it's 8 marks. Learn. I beg you guys, learn this. Now we got x plus 10 is equal to 180 minus 90 minus 2x plus 20 plus k times 360. So x plus 10 is equal to 180 minus 110 minus 2x plus k times 360, where k is an element of integers. X plus 10 is equal to 180 minus 110 plus 2x plus k times 360. Remember, we're removing the brackets. We're solving for x. X minus 2x is minus 1x. 180 minus 110 is 70. Minus 10 is 60. Plus k times 360, where k is an element of integers. So your final answer, x is equal to, divide by negative, minus 60 minus k times 360, where k is an element of integers. And there we go. That's how you will unpack this problem in your final exam. Yes, it's a lot of work. That's why it's worth 8 marks. And it's easy. All you have to do is change the cos to sine. Drop the 2 signs, split it up. First general solution, first quadrant, or 180 minus in your second quadrant, and give your 2 general solutions. Right, here goes. Carry on. Take this one down. Let's check our comments coming in. Are you guys following? Boitumelu, love this. Mpumi Dlamini, thank you, Seth. K times 120, Tristan, we divided by 3. I circled it. Tristan, hope you're paying attention there. We divided by 3. You divide that by 3. You divide 360 by 3. That's how you get the 120. Hope that answers your question, Tristan. Yes, Tabelo. Malu Kuchle Bengu. Got it, Poppy Pizza. Hey, pizza in the house. Killing it. Killing it. Well done. I'm seeing all your comments coming up on the side. South Africa, we love you and we want you to get distinctions. We want full A's. Full A's. Destination distinction. Is the final answer supposed to have minus 360? Yes, because we're dividing everything by negative. We're dividing everything by negative. Right, for those of you who took this one down, start with the next. Start with the next, yes? Sorry? I'm not with you. It went to the other side. This 2x comes on the other side as minus. So 1x minus 2x becomes minus x. Right. Prove the following identity. Prove that cos x plus sin x all over cos x minus sin x minus cos x minus sin x all over cos x plus sin x is equal to 2 tan 2x for 5 marks. I'll tell you which paper this one comes out. November 2018, final paper. This comes from November 2018. Final paper. Let's do it together. The next one is going to kill you. We're going to do a couple of problems here, guys. We still got some reduction. We got some diagrams to do. Let's do this together. I hope you guys are activated. South Africa, are you following? Are you online? Let's go. Let's go. Left-hand side. The left-hand side. We use algebra. So, left-hand side. Let's all do it together. We're finding the LCD. So you got cos x minus sin x into cos x plus sin x. Guys, at this point in time, if you don't know how to find LCD and you can't add or subtract fractions, please leave maths. It's not for you. Cos and cos will cancel. We're left with cos plus times that times the numerator would be cos x plus sin x into cos x plus sin x minus that, and that will cancel. Cos x minus sin x times cos x minus sin x is cos x minus sin x into cos x minus sin x. Let's remove the brackets. I only did the LCD here, lowest common denominator. Now, this is going to be FOIL it, first, outer, inner, last. Cos squared x plus sin x cos x plus another sin x cos x plus sin squared x minus, in brackets, cos times cos is cos squared x minus 1 minus another 1 minus 2 sin x cos x. I just did outer and inner together, plus negative times a negative is a positive, sin times sin is sin squared x all over cos times cos is cos squared x minus sine times sine is sine squared x. Let's remove the brackets. Cos squared x plus 1 plus 2 sine x cos x plus sine squared x minus cos squared x plus 2 sine x cos x. I'm multiplying this negative inside. Minus sine squared x all over cos squared x minus sine squared x. We're not yet done. Right. Let's collect like terms. Cos squared x minus cos squared x. Gone. Sine squared x minus sine squared x. Gone. 2 sine x cos x plus another 2 sine x cos x is 4 sine x cos x over cos squared x minus sine squared x. Now watch. Here comes the trick. Here's the game now. Here's the game. Follow. Let's take out 2 from there. 2 into 2 sine x cos x over cos squared x minus sine squared x is your cos double angle, cos 2x. So there's the 2 outside. 2 sine x cos x is your double angle for sine. So it's sine 2x over cos 2x. Bang! There's your final answer. 2 tan 2x, which is equal to your right hand side, like a boss. Learn this one. Remember, this is your sine double angle. This is your sine double angle. This is your cos double angle. And sine over cos is tan. You can get up to 6 marks for a question like this. Maths is not for the weak. That's it. That's it. It's not complicated. All you have to do is know your formulas. Yeah. Normal. This is not higher order. This is normal. Come on. LCD, collecting like terms and finding your compound and double angle in it. This is your bread and butter questions. This is a level 1 question. If you're thinking this is level 2 or level 3, you've got problems coming up in life. Well, the next one is a level 4 question. I like the next one. I'm loving the next one. Mosima Sedibana, you are seeing dust. How did I get cos 2x here? Come on, isn't that your double angle? There's your double angle. Cos squared x minus sine squared x is your double angle for cos 2x. Marwena. Learn. I beg you, learn and practice. Learn and practice. You guys want to sit till 4 o'clock today? You are in Maths church. I'm the pastor. I will bless you. Evaluate without the use of a calculator for 5 marks. This one is going to show many of you flames. Kway students, you're going to smile. You know how to do it. Sigma, 52 degrees. A equals 38. Cos squared A. Boom. There's a sigma in trigs. Have you seen this one in school? No. It's here. It's going to show you flames. I'm going to show you how to do this one like a boss. Guys, you better be paying attention. You can't be messing around. The only thing that is maths is serious. The only thing more serious than this is AIDS. The only thing more serious than what we're doing right now is cancer. That's how serious we are. Mpumi, if you can't see nothing, it's your internet, Baba. Make sure your internet is solid. Lutando says, yo, I should have rather just stayed an egg. Oh my word. Oh, these people, they are rough. Come now, I have to take this thing out. Come, let's go, let's go, let's go. Come guys, stop messing around and start working. Little bit of comic relief here and there is fine. But you know how serious this work is. Let's go, let's go, let's go, let's go, let's go. Let's go, let's go, let's go, let's go. Then it's a problem, bro. What I'm here to do is to give you the chemo in the cancer of math. Let's go. Watch here. Many of you are bombed. Many of you are bombed with this one. Let's see. Offense, you waiting for second break. The rest of the country is waiting to get a distinction for this question. Right, who's got this? Come, I show you. Point of view. How do you know how to even begin the question? Because the maths is mathsy. Now, from C, here's your answer. Pay attention. Right, all of you, onliners. Uriel Ngobeni, I think you might be right. 7.5, 7.5. I think you're right. Ietu Ngobo, first time to see a trig sigma. You do the same thing. Watch. Sigma notation, we start putting in 38 here. Cos squared 38 plus, next one is 39. Cos squared 39 plus cos squared 40 plus cos squared 41. Pay attention and watch. Plus cos squared 42. We need to go right up to 52, but watch what happens. Plus cos squared 43 plus cos squared 44 plus cos squared 45 plus, now 46. Watch here, cos squared 46 is the same as saying sine squared 90 minus, what's this? 90 minus what will give me 46? 44. That's cos squared 46. Wait. Plus sine squared. Now, cos squared 47 will be 90 minus 43. Plus sine squared 90 minus 42. Right? So we're going down again. Plus sine squared 90 minus 41. Plus sine squared 90 minus 40. So I must go up to 52, right? 45, 46, 47, 48, 49, 50. I got two more to do. Plus sine squared 90 minus 39. Plus sine squared 90 minus 38. Now watch here. We know, listen, we know that sine squared 90 minus 44 is cos squared 44. Cos squared 43. Cos squared 42. Cos squared 41. Cos squared 40. Cos squared 39. Cos squared 38. Right? So now we know, listen, watch here. Cos squared 38. Yeah, plus sine squared 38. Just give me a second here. That's cos squared 38. This is sine squared 90 plus cos. What's going on here? We know this has got to be sine squared plus cos squared. Okay. Let me just check here. Something's not right here. Wait, for cos squared 45. Sine 45. This has got to be cos squared 46, right? Cos squared 46 is the same as saying sine squared 90 minus 46. Yes, that will give 90 minus 44. Sorry, 90 minus 44. You're supposed to get sine squared plus cos squared. You're supposed to get sine squared plus cos squared, and that's supposed to give you a 1. Everything here is supposed to give you a 1. So, cos squared 38. Cos squared 90 minus, wait. Something is not, we are mathsing here. So cos squared 38, that's all right up till cos squared 45. Cos squared 45. Give me a second. Plus cos squared 46 is wait, I'll get it here. Relax. This thing changes again to cos squared 38. It can't be 2 cos squared 38. Cos squared 38 plus cos squared. It can't be 2 cos squared. It's got to be sine squared. Okay, give me a second. I'm going to take all this out afterwards. Let's crack this. Wait. What did I do wrong here? Give me a second. Let me correct myself. Alright, so we got cos squared 38, cos squared 39, cos squared 40, 41, 42, 43, 44, 45. Okay, let's just put it as cos squared 46 plus cos squared 47 plus cos squared 48 plus cos squared 49 plus cos squared 50 plus cos squared 51 plus cos squared 52, right? Because we had to take it all the way up to 52. Just give me a sec. We know cos squared 45 is root 2 over 2 squared. Cos squared. I know where I went wrong. So, yeah. This is where I went wrong. Okay, so this is correct, yeah? Now, 46. 46 is the same as saying 90 minus 44. 46 is the same as writing 90 minus 44 plus 47 is the same as saying 90 minus 43. 48 is 90 minus 42. 49, 90 minus 41. 50, 90 minus 40. 51, 90 minus 39. 52 is what? 90 minus 38. So now you're going to get cos squared 38 plus cos squared 39. Now remember, okay, let's skip a step here. I'm not going to rewrite everything. Watch here. Watch. This is equal to cos squared 38. Cos squared 90 will change to sine squared 38. So cos squared 38 plus sine squared 38 is 1. Right? Sine squared plus cos squared is 1. Cos squared 39 plus sine squared 39 is 1. Cos squared 40 plus sine squared 40 is 1. Cos squared 41, sine squared 41 is 1. Cos squared 42, sine squared 42 is 1. Cos squared 43, sine squared 43 is 1. Cos squared 44, sine squared 44 is 1. Cos squared 45 is root 2 over 2 special angle squared. 1, 2, 3, 4, 5, 6, 7 plus root 2 over 2 squared is root 2 squared is 2 over 2 squared is 4. 2 over 4 is a half. Your answer is 7.5. And there we go. That's your final answer for that question. Sigma notation. Sigma notation in trigonometry. Right, one more component of trigs to wrap up this compound and double angles. Another, and I'll tell you where's this one coming from. Let's check our onliners. Did they all die in this question? Can you use Sn equal 2a plus n minus 1 times d? No. I don't know, try it. The person who asked that question, see if you got the same answer. Jacques Groenewald, if you do it, send it through. But learn this question. Right, here's the last trig component. Right. if sine 11 equals P? Fine. Question number 1, sine 191 cos 22 sine 5 comma 5 in terms of P. Mark allocation, 3 marks, 3 marks, 5 marks. Quiet, quiet, quiet. Right, let's go. Now here, whenever you see this, this is called trig substitution. We have to draw a triangle. You know sine is opposite over hypotenuse, so that's P over 1. Yes or no? And they don't give you a restriction, so you can draw your triangle in your first quadrant. Sine 11, opposite over hypotenuse for sine, you know, SOHCAHTOA. Sine opposite over hypotenuse, P over 1. And this would be positive because it's to the right. The square root of 1 minus P squared, if we use Pythagoras. Yes or no? Let's check here. Onliners, I hope you got this. Did you guys get this one? Did you guys get this one? Right. Now answer the 3 questions. Answer the 3 questions. I've got another question like this coming up afterwards. Thanks, Zuer, Lutando, Ieto. Right, let's go, let's go, let's go, let's go, let's go. Shh, quiet. So, in your answer, this is step number 1. Step number 1. Step number 1, you draw your triangle. Sine is opposite over hypotenuse, so it's P over 1, and that is the square root of 1 minus P squared. Let's answer the question. Sine 191. We need a 11 degrees. So it's sine 180 plus 11. Goes. That is equal to sine 180. The name stays the same. Sine 11. 180 plus is in my third quadrant. Sine in my third quadrant is negative. They want your answer in terms of P. So that's minus, and sine 11 is P. That's your answer for question number 1, minus P. Yes or no? Do number 2. Cos 22. What is the relationship between 22 and 11? That's cos 2 times 11, your double angle for cos. But we want it in terms of sine. This is your double angle for cos. So it's 1 minus 2 sine squared 11, which is equal to 1 minus 2 sine 11 is P squared. And that's your final answer for number 2. Let's see who gets number 3 right. Your number 3 is the killer. Number 3. And remember, if you got the first 2 right, you only got 6 out of 11 marks. The last one there is 5 marks. I can even make the last one 6 marks. Listen here. Let's make the last one 6 marks. That means you could have got the first 2 questions right. If you get the last question wrong, you only got 50% for this question. That's how important the last question is. I want sine 5 comma 5. Okay, Iman. So you say this is the easiest part of Trigs, Iman B. So let's see how you do the last one. Bushe, we're going to do Euclidean geometry last, before we leave, from about 2 o'clock to 3 o'clock. Watch here. Let me show you some magic now. Put your pens down. We're now going to answer the last one. The last one's going to get rough. Watch and learn. To answer sine 5, 5, you start off with cos of 11. You start off with cos of double the angle. Now cos 11 is adjacent over hypotenuse. So cos 11 is equal to square root of 1 minus p squared over 1, which is still square root of 1 minus p squared. So many of you might ask, why do I start off with cos 11 to get sine 5, 5? Watch. This is the trick of this. Pay attention. If you're not going to understand, if you're not going to follow me now, you're gone. You'll get 0 for this in your exam. Watch here. Cos 11 is cos 2 times 5, 5. So that's your double angle for cos. But remember, your double angle for cos to get a sine is 1 minus 2 sine squared 5, 5. And that's how we're going to get to sine 5, 5. Is equal to the square root of 1 minus p squared. All we're going to do now is make sine 5, 5 the subject of the formula. So minus 2 sine squared 5, 5 is equal to the square root of 1 minus p squared. The plus 1 will come on the other side as minus 1. We'll divide this side by minus 2. That and that will cancel. We divide that by minus 2. We're now going to go on to this side. I'm just going to move over to the side because I don't have space. So now we got sine squared 5, 5 is equal to a negative divided by negative is a positive, so it's 1 minus square root 1 minus p squared all over 2. And now I want sine 5, 5. So therefore, here's your final answer for sine 5, 5. Therefore, sine 5, 5 is equal to the square root of 1 minus root 1 minus p squared all over 2. Like cos. You start off with cos of the double angle, convert it to sine. So whenever you get half of an angle, you start off with cos of the double angle. Are you with me? Learn. I beg you, learn this. This is straight out of a past paper. We're going to do one, in fact, we're going to do quickly 2 more before break. 2 more before break. It's 20 to 1. What time did we come in? 11:30, 25 to 11:30. We came in 12:30. Oh, we got time. We still got 20 minutes. 1 o'clock we go for break. And we're moving at a fantastic pace. Onliners, I hope you learn this. Take this one down. You thought you knew maths until today. You thought you knew maths until today.
Fatality.
Well done, Denzel. This year will tell you now, today, after this weekend, you know how prepared you are for your June.
Final round.
Some of them are re-evaluating their life goals today. You became the maths.
Flames. We're seeing flames, Mr. Kauta. There's smoke coming
Angkor.
out of the carburetor.
Learn this. Divinely, you thought you knew. Welcome to Kway. It's like this. Come on, wait. You know, there's so much I want to teach you. There's so much I want to show you. We have so little time. Yes, I have a world of question banks in my head. Check this next one. Okay, let's see what bosses are you. Use the same scenario that I gave you now to answer the next question. And let's see how sharp are you. Come on. Sharpen the pencil in the brain. Watch here. Watch here. Watch here. Watch here. The next question for those of you who just want to try something. Check this out. Okay. I hate to say this. Kway students, you know what to do. Find sine 22, 5. If f of x is equal to sine 22, 5, find the value of f of x without the use of a calculator for 6 months. It's exactly the same like the previous one. Let's see how sharp are you. Come, be a boss. No triangle. You don't draw a triangle. Because 22, 5 is related to which special angle? 45. Now here 5, 5 was half of 11. Here 22, 5 is half of. So you follow the same thing. You're going to love it when I do it now for you. Maths is mathsing. Right, you want me to do it for you quickly? Yes. All right, let's do it. I'm going to start off with cos 45 is equal to root 2 over 2. That is your special angle, yes or no? Now pay attention, don't write. So cos 45 is cos 2 times 22, 5. It's exactly what we did previously. So cos of the double angle is 1 minus 2 sine squared 22, 5 is equal to root 2 over 2. Now take the 1 on that side. Minus 2 sine squared 22, 5 is equal to root 2 over 2 minus 1. Minus 2 sine squared 22, 5 is equal to, your common denominator is 2, root 2 minus 2. Now we divide by minus 2 or times it by minus 1 over 2. We times that by minus 1 over 2. So that and that will cancel. Sine squared 22, 5 is equal to negative times positive. Negative times negative is a positive minus root 2. All over 2 times 2 is 4. Your final answer. Here's sine 22, 5. F of x. Sine 22, 5 is equal to the square root of 2 minus root 2 over the square root of 4 is 2. And there we go. That's your final answer and you'll get 6 marks for that. It's exactly the same as the previous concept. I thought I'd just show it to you. I didn't even plan on doing this one for you today. But never mind. Let's just do it. We are here. We might as well do it. Bet you never saw this before. But it's examinable. I'm telling you, learn this. Never saw this before, right? Right, onliners, we got 2 questions to do before break. Yes, sir. Ntando. Yes, sir. Ietun Kobo. Beautiful, Sam. It's a work of art. Zuer, let's go. Neo MK, you are actually learning. Yes, of course. What do you think? You think I'm here to waste your time? You think I got time to waste and you have time to waste? You think I'm going to waste the grade 12's weekend, a week before they write the exam? You see mad written on my head. Thank you, Mai. Let's go, let's go, let's go, let's go. This is so fun. Bring more on. Divinely. Larato, wow. Thank you, thank you, thank you. Thumbs up, thumbs up, thumbs up. This is when you learn, Baba. This is where you learn. Kway and Awqaf. I'm here to show you tricks. Watch here, watch here, watch here, watch here. Let's go. I'm clearing the frame. Okay, let's take that question. Those of you who took this one down, start with the next. We got 2 more to do. Simplify. Simplify. Cos x minus 180 plus root 2 sine x plus 45 to a single trig ratio for 5 marks. Simplify to a single trig ratio. We got 1 more after this to do, then we go for break. Go for it, go for it, go for it. Onliners, come, 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 come. Latabo say, going to start art next year. Questioning life choices now. Bara bing, bara boom. Magic maths, mathemagics. We are here to do mathemagics, Baba. Let's go, let's go, let's go. Guys, I'm asking you straight out of past papers. I'm asking you straight out of past papers. Let's go, let's go, let's go, let's go. Come, I do it for you. Let's do it together. Shh. Right. Cos 180 will stay cos x. But be careful. Cos is in my 4th quadrant. Shh. I'm moving 180 degrees anti-clockwise. So from here to here is 90. From there to there is 180. So I'm moving 180 degrees anti-clockwise. Pay attention. Shh. What is cos in this quadrant? Right, pay attention. Plus root 2. Sine x plus 45 is your compound angle. Sine cos, cosine, x 45 plus x 45. So we moved 180 degrees anti-clockwise. Now there are many ways to do that. Sometimes your teachers in school show you how to do it like this. They say cos, flip it over, minus 180 plus x, no problem. Then they tell you make it a negative angle, cos minus into 180 minus x. Then they tell you, then you know cos of a negative angle is positive, cos 180 minus x. Then cos 180 will become cos x. 180 minus is in your 2nd quadrant, cos is negative. See, we get the same answer. I showed you a shortcut. Instead of you doing this 4 steps, all I did, I told you here, cos 180 name stays. Cos is in this quadrant. We're moving 180 degrees anti-clockwise. So we land there. What is cos in this quadrant? There we go. So this diagram replaces all of that. I'm showing you a shortcut. Does it make sense to you? Learn this. I call it the dial method. The dial method is so much easier than doing 4 more steps of converting them to negative angles. So avoid this. Avoid the bottom part. Right, let's do this. Let's continue. Minus cos x plus root 2 into cos 45 is root 2 over 2 sin x plus sin 45 is root 2 over 2 cos x. Now you can say root 2 over 2 or 1 over root 2 is the same thing. So that's minus cos x plus, that's over 1. Root 2 times root 2 is 2. Over 1 times 2 is 2 sin x plus 2 over 2 cos x. That is equal to minus cos x plus sin x plus cos x. Minus cos x plus cos x cancels out. What am I left with? So they can make this, or they can say prove that this is equal to sin x and make it an identity. You'd still do the same thing. Only thing at the end you'll say therefore left hand side is equal to right hand side. Now the next one is the last one before break. Learn this important. Sin x, divinely, well done. Ketobili, well done. Aisha, well done. Vision, you want an autograph? No problem. There's my signature. Just for you. Go, 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 go. Right. Those of you who have done this one, I know you've taken it down. Let's see if you can do the next one, the last one before break. Given, check this one out. You are given sin P plus sin Q is equal to 7 over 5. And P plus Q is equal to 90. Without the use of a calculator, find sin 2p. Not sin squared p, sin 2p. No calculator. For 6 marks. Last question before break. To keep your brains hot. Hasanain, how are we doing there on that side, bro?
We're Lankif, bro. We're smoking.
Come do this one, Machana.
Just do that thing, my China. Ride that wave, dude.
Ride the wave, dude. Bring the surf. Surf's on. Surf's on, dude.
It's very gnarly. Lank gnarly.
Gnarly, bro. This question separates the men from the boys. Let's go, let's go, let's go. Let's see how sharp are you. Shh. Come. I'll give you guys another minute or two. There's condition number 1. And there's condition number 2. And that is your question. Find sin 2p without the use of a calculator. Now they want, come on, okay, one more minute. Come on, I'll give you guys 1 more minute to try and figure this one out before I work it out for you. We're almost for break. We are almost there. I hope you guys enjoyed the second session. Was a bumper session. We did amazing questions. I hope you now are haunt in math, in trigs. Yeah, ne.
What's for lunch, Mr. Kouter?
A steak box.
Steak and pap.
Steak box with gravy and chips and they make a mean steak box here. Quota is for lunch. Come on.
Let's have a quarter for lunch.
Banguinia and meals. Let's go. Right, let me give you the answer. This is where you answer. Look at this. Now, many of you don't know where to start. Watch here. Shh, girls. Girls, ladies. Right, pay attention. Your answer is only in terms of P. That means get rid of Q. So we know that P plus Q equals 90. So Q is equal to 90 minus P. Right? From there. Now take this and put it in there. Therefore, sine P plus sine Q, 90 minus P, is equal to 7 over 5. Now I got everything in terms of P. So sine P plus sine 90 will change to cos P. 90 minus is in my first quadrant. Sine is positive. Is equal to 7 over 5. We need to get sine 2p. Remember, that's where destination sine 2p. Now watch. I show you magic. Now we square this side and we square this side. So that will become sine squared p plus, you multiply the 2 and times it by 2, like x plus h in calculus, 2xh. So it's 2 sine p cos p plus cos squared p is equal to 7 squared is 49 over 5 squared is 25. Now sine squared p plus cos squared p is 1 plus 2 sine p cos p. And there's it. There's it. Sine 2p is 2 sine p cos p. Don't worry, we're getting there. 2 sine p cos p is equal to 49 over 25. Therefore, take this 1 on the other side. 2 sine p cos p is equal to 49 over 25 minus 1 minus 25 over 25, which is equal to 24 over 25. Therefore, sine 2p, therefore, this is sine 2p, there we go. Therefore, sine 2p is equal to 24 over 25 is your final answer. That is your double angle, sine 2p. There we go. That's what they want. Bumper session, guys. What a bumper session. I hope you guys have mastered this. This came out of your November 2019 paper. So learn. They're going to ask you these styles of questions. June, prelims, and final. Rabia, that was so beautiful. She's crying. I know math has a tendency to leave that corner tear in the corner of your eye. Well done, well done, well done, well done, guys. We now off for break. I think we will resume at 1:45, guys. Let's take a 45-minute break. I'll do a circle analytics component and Euclidean, and that will take us to 3 o'clock at the end of today. So, guys, I hope you guys enjoy your break. Hasanain, thank you so much. We've had a super bumper session.
Mr. Kota, what time will we resume? At quarter to 2?
1:45, 13:45.
13:45.
Resume at 13:45. I'll just put it up here on the screen. I'll put it up on the screen. We resume
Don't worry, I've got you there, Mr.
at
Kota.
yay. Come
Here
on.
we go. That was fun. Get some
Thanks,
rest, Mr.
Hasanain.
Kota.
Thank you so much for the
Relax
lower
your
third.
vocal cords, and we'll see you on the other side of this break.
Super session, guys. Super trig session. What a bumper session we had.
So there we go. We currently on a break. Use this opportunity to get something to eat, pray if you need to pray, and stretch your legs. And we will resume at quarter to 2. We'll see you there. Welcome back to the grade 12 Maths workshop hosted by Awqaf South Africa in association with the Department of Basic Education and the Kway Institute as well as iSkill. We are currently coming to you live from the Ghazali College in Pretoria. We have a cohort of grade 12 learners that's in person with Mr. Kota, as well as the educators of the Ghazali College, which is a school in Pretoria, and they have graciously hosted this hybrid session today. So we have some in-person participants as well as our fantastic audience online. You've been amazing. Keep that comments flowing. Um, we will be hosting a competition at the end or maybe in the new year. We will be hosting a competition for all of you that have participated in this competition. We will be awarding cash prizes for first, second, and third place. All that you need to do, you need to register as a participant. And when the competition does open, it will open in January 2024, especially for you grade 12 learners. You will only receive your results in January 2024. So the competition will be open then. So we will be sending email communication to you closer to the time, perhaps closer to January 2024, with information where you need to submit your results to our online form. All that you need to do is submit your June examination result as well as your final examination result. Perhaps that's in October, and we will be awarding top prizes for first place, second place, third place, um, as well as the most improved learner. So we are going to be opening up this competition to the workshops that we're hosting for grade 10, 11, and 12. So look out for that. You can win some cash prizes there. So if you have missed out on the sessions because of load shedding or your internet connectivity is a little bit low, it's dropped off, you can refer back to the Awqaf SA website. Let's get that on the screen here for you. We're going to show you on the Awqaf website. On the landing page, this is the Awqaf SA website. This is the social media click-through buttons. This is the YouTube one. But what you can do is there is a click-through to the Awqaf Maths workshop page. So this is essentially the event page for the Awqaf SA workshop, and all of the videos of the past sessions are embedded on the website. And these videos are essentially videos from the YouTube session. So what we will do is we will be popping the grade 12 videos for you. We will be inserting it into that page. So we thought that we'll share that information with you. And just looking at this is what the setup looks like at the Al Ghazali College. Lots of the learners are getting ready for this session. This is like the final leg of our workshop. And this is some of the photos that we took earlier on during the course of the day, submitted by Mr. Kota. What a happy bunch. There we go. High energy. That's the cohort of learners, grade 12 learners. That's keeping Mr. Kota on his toes. So there we go. Thank you for your comments. Yes, indeed.
Here we go, here we go, here we go. Final battle.
Final round.
Final round, final battle. Last stretch. How you guys? How you guys? How you guys? We all back in the game. We got the last round until 3 o'clock. It's 10 to 2. Let's go, let's go, let's go. Thank you, hasanain.
Are you ready to rumble, Mr. Kota?
We are ready to rumble. Just want to thank Awqaf South Africa, thank the schools and all the learners for participating online and on site. Thank you guys. Let's go, let's go, let's go. We stopped here. Let's start with analytics. Let's give you a scenario. Let's give you a scenario in analytics. Let's clear. I'm going to combine analytics and circle analytics before we do our. So let's just go page not responding. Let's just see what's it saying here. Let's go back to StreamYard. We all okay? Let's go back here. Exit page. Oh snap. Let's go reload. Let's check it. Reloading. The matrix reloaded.
Aish.
Reloaded. There we go. We're coming back on. There we go. I think we reloaded. Am I live again there, hasanain?
Let's have a look.
Is it presenting?
Now
Are
you
we
need to
good to
present.
go? Do I need to present again? So let's go
Yes,
again.
sir.
Let's present. Share screen. Share screen. And we got the Jamboard. And we should be live any second now. There we go. Danko.
Danko.
Let's go. hasanain, we live?
Yes,
We
sir.
good to go?
Take it away.
Let's go, let's go. Right, guys, do me a favor. Take this diagram down. Take this diagram down. What I'm going to do, I'm going to do that. I'm going to do this. I'm also going to do that. I'm going to give you the radius here. I'm going to tell you that the equation of the circle, let's give you that point P. Let's tell you that is 2, and 2 on my X, 6 on my Y. Take this diagram down, guys. Take this diagram down. Here we go. That's the radius. 2 and 6. I'm going to give you a point here. I'm going to tell you that is point B. I'm going to tell you that is point D. That is 0. That is X. And that is your Y axis. Come, let's go. Let's go. Breaks over, breaks over, breaks over. Okay. I'm also going to tell you that the distance between there and there is 5. I'm going to tell you that the radius is 5. We got a point there, 2 and 6. Okay, let's go. So question number 1. What I'm also going to do is give you a line coming down there. And I'm going to call this angle here angle theta. Here goes, here goes, here goes. And we're going to call this point point N, and N's coordinates is 1 and 0. Right, question number 1. I want the equation of the circle, in the form x squared plus ax plus y squared plus by plus c equals 0. Number 2, find angle theta, the value of angle theta. Question number 3, I want the equation of the, I'm going to make this even more interesting. I want the coordinates of D. Mark allocation for the first one, 4 marks. Find angle theta, 3 marks. The coordinates of D, 5 marks. Question number 4. Another circle with center T, 12 and 8, and a radius of 3 is drawn. Will the two circles intersect? Show all calculations. Will the two circles intersect? Show all calculations. For 6 marks. There we go. So here's an exam scenario. There's an exam scenario. And let's put one more question there. Let's add one more question. If x squared plus y squared minus 6x plus 10y minus 2 equals 0, find the coordinates of the center of the circle and the radius. Find the coordinates of the center of the circle and the radius for another 3 marks. So 4 and 3 is 7, and 5 is 12, and 6 is 18. Make this 2 marks. Let's make that 2 marks. So then we make that a full exam component of 20 marks. So here we go. Let's check all our, right, here we go. You guys still on fire there? Take this one down. Take this one down. These are your 5 questions for 20 marks. In your paper 2, you're going to get 2. You're going to get 1 analytics for 20 marks, 1 circle analytics for another 15. So it will probably be between 35 and 40. Your data handling, another 20 marks. That's 60. Trigs, another 40. That gives you 100. And then 50 for Euclidean. And Euclidean, I'll show you when we get to it. It's very easy. Your grade 11 component is half of it. Grade 12 is the other half. But the higher order is only 10 marks out of the 50. Only 20%. You can still score 95% for paper 2. You can still score 95% for paper 2. Right, so we want the equation of that circle. So I'm going to be flipping between pages. If this is our questions, let's answer question number 1. Let's all do this together, and then we're going to start with Euclidean. So we got the center, we got the radius. So all we're going to do to answer question number 1, I'm just going to clear that. Let's go. Answer question number 1. What was the center? P, 2, and 6. What was the radius? 5. So x minus x1 squared plus y minus y1 squared is equal to r squared. Where x1, y1 is the center. So x minus 2 squared plus y minus 6 squared is equal to 5 squared. In fact, what we can do now, they want it in expanded form. They want it in expanded form. So we're now going to say x squared minus 4x plus 4 plus y squared minus 12y plus 36 minus 25. The plus 25 will come onto the other side as minus 25 is equal to 0. So x squared minus 4x plus y squared minus 12y. 4 plus 36 is 40. 40 minus 25 is 15. Plus 15 is equal to 0. That is your final answer. We got it in the form x squared plus ax plus y squared plus by plus c equals 0. That's the way they wanted it. That's the way we answer it. And we're getting our first 4 marks for that. We're using the center of the circle 2 and 6 and 5. Right? So let's just go back there. And there we go, guys. Take that down. That's your first 4 marks for your analytics or for your circle analytics. We're going to work quite fast. We've got quite a bit of work, not too much. Pay attention, take this down. It's not difficult work. Please make sure you learn your formulas. Please make sure you learn. That is the equation for for a circle whose center is not at the origin. There's it, x squared plus y squared equals r squared, but now the center has moved. So x minus x1 squared plus y minus y1 squared is equal to r squared. Are we all okay here, guys? Well done, well done, well done. Onliners, I hope you all got that one right. Euclidean, we're doing this after this. See here? We are doing Euclidean after this. That is question number 1. Did you all get that, onliners? Did you get that one right? Did you get that one right? Good. Let's go. Next one, next one, next one. Question number 2. Find angle theta. So let's answer question number 2 here. Let's answer question number 2 here. Now we know that tan theta is equal to the gradient of the line where the arrow touches. So tan theta is equal to, now which line are we looking at? We're looking at this line here. That's the line where theta touches. So it's y2 minus y1 over x2 minus x1. So tan theta is equal to 6 minus 0 is 6 over 1, which is 6. Theta is equal to shift tan 6. Let's go to our calculator. We use the shift key on our calculator. Shift tan 6. We don't use sine, we don't use cos. Angle of inclination is always tan. Shift tan 6. 80,5 degrees. There we go. We got 80,5. So that's our next 3 marks. Now the next question for 5 marks. Calculate the coordinates of D. We can say if BD is a tangent. If BD is a tangent. Let's see how we would do that. If BD is a tangent, how will we calculate the coordinates of D? There's D. There is D. So let's do it, guys. Let's do it together. Now D is the y-intercept. D is the y-intercept of BD, and BD is given by y is equal to mx plus c. We just need to find c. That is your D's coordinates. That means we need to find the equation of the tangent. What does that mean, guys? We need to find the equation of the tangent. So how do we do that? How do we do that? Let's say B's coordinates. Okay, so the first thing we're going to do is we're going to draw. Now wait, just give me a second. I meant to draw this way, where this was a straight line. So relax, don't stress. Don't stress. Right, I wanted that line to be straight coming here. And that would have been point N. Right, that line there. That line there. That is point N. So if this is a straight line, that's a straight line. That means we need, what do we need? We need a gradient and we need a point. So we can find, we don't have the gradient, but we know that the gradient on the top is equal to the gradient at the bottom. Because these two are radii. Am I right? Good. Now let's give you a point on the slide. Let's tell you that this point here is, let's just say 10 and 12. Let's say point B is 10 and 12. Let's say point B is 10 and 12. And we need to find the equation. So how do we do it? Watch here. I'm just going to move up here. Let's see if we can squeeze it in on the top. We want the coordinates of D. So this is the way we answer it. So we're answering question number 3, guys. So the M of BP is equal to the M of Pn. Why? It's a straight line. They are collinear. They are collinear. We calculated the gradient there. The gradient was 6. Therefore, the M of BP is equal to 6. Because the M of this line here was equal to 6. It's a straight line. So the M of that line is also equal to 6. Yes or no? Therefore, the M of your tangent is minus 1 over 6. Why? Because your radius, according to Euclidean, your radius is 90 degrees to your tangent. Your radius is 90 degrees to your tangent. Now, we got the M of this line, which is minus 1 over 6. And we got a point, 10 and 12. Now, obviously, I don't have enough space. Let's see. Maybe I can do it here at the bottom. Maybe I can do it here at the bottom of the screen. I'm still answering question number 3. I'm just moving to the bottom here because of space. So, guys, all I'm doing, I'm moving from here to there. So that means the equation of BD, is going to be y minus y1 equals m into x minus x1, or y is equal to mx plus c. We got a point, we got a gradient. Just substitute. So work that one out, guys. Substitute, get me the Q value, and then thereafter get me the coordinates of D. Let's see how you guys do that. Let's work it out together. Y minus 12 is equal to m minus 1 over 6 into x minus 10. Y minus 12 is equal to minus 1 over 6x plus 10 over 6 is 5 over 3. Your final answer, y equals minus 1 over 6x, 5 over 3 plus 12. 12 plus 5 over 3. Boom. 41, 13,67. So what is D's coordinates? Where do we take D's coordinates from? From there. So D, because D is the y-intercept of this graph. 0 and 13,67. So step number 1, we needed the gradient. Step number 2, radius 90 degrees to tangent. Step number 3, the equation of the line. Step number 4, extract the y-intercept. Are you all following? Take this one down. Step 1, step 2, step 3, step 4. Onliners, you guys following? Yes, Bouchlet, D 0 and 41 over 3. Well done. Well done, well done, well done. Those of you who are done with question number 3, start question number 4. Another circle with center T, 12 and 8 and a radius of 3 is drawn. Will the two circles intersect? Show all calculations. Now you cannot draw that circle. It's got to be done by calculation. What do we know about circles that intersect, circles that touch, or circles that do not intersect at all? Do you guys know those rules? No? Did you forget those rules? No? Were you not shown those rules? Right. Let me quickly give you the rules here. Wait. Let me clear the frame here. Okay, I'll give you another minute there on that previous screen. Take this down. Take this down. Who knows the rules about two circles? Relationships between two circles. Don't know it. If the distance between the centers is greater than the sum of the radii, they will have no points of intersection. You don't know it. You know it. You were going to say that. Yeah. On planet Jupiter. Right. Listen. If the distance between the centers is greater than the sum of your radii, then they will have no points of intersection. If the distance between the centers is greater than the sum of your radii, they will have no points of intersection. Learn. If the distance between the centers is less than the sum of your radii, that means the distance between your centers is less than the sum of your radii, they will have two distinct points of intersection. And if your distance between your centers is equal to the sum of your radii, then the two circles will just touch. The two circles will just touch. And another word for touch is tangential. They might ask you in the exam, will the two circles be tangential? Means will they just touch externally at one point? I'm teaching you some English here. Learn this. You have to know it's part of your kit of your toolkit of rules. Onliners, have you seen this? Zoher, where can't you see? Check. If you can't see, it's crystal clear. You'll have to check your internet connection. Distance between centers greater than sum of radii. No points of intersection. Distance between centers less than sum of radii. Two distinct points of intersection. Distance between centers is equal to sum of your radii. The two graphs are tangential. Remember this. So now let's see. Now compare. Now answer that question. That was for how many marks? 5 or 6 marks. Yeah. Another circle with center T. So we had two circles. What was our first circle? Our first circle, the center was 2 and 6. Remember, our first circle, the center is 2 and 6, and it's got a radius of 5. The second circle is T, 12 and 8, and it's got a radius of 3. Now let's work this one out. So we need to calculate distance between centers and sum of radii. So this is the way you do it in the exam. So sum of radii is 8. Distance between the centers, PT, equals the square root of x2 minus x1, your distance formula, all squared, plus y2 minus y1, all squared. PT equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. PT is equal to the square root of 10 squared is 100 plus 2 squared is 4, which is equal to the square root of 104, which is equal to the square root of 104, the square root of 104, 10,2. 10,2. What can we see? We can see that the distance between the centers, is greater than the sum of your radii. Your distance between centers is greater than the sum of your radii. Why? Because 10,2 is greater than 8. So therefore, let's go back to this. Distance between centers is greater than the sum of your radii. So what will it be? No points of intersection. Very good. Therefore, no points of intersection. So let's go back. And we say, therefore, no points of intersection. Right, distance between centers is greater than the sum of your radii, therefore, no points of intersection. The two circles will not intersect each other. Are you all following? Onliners, on-siters, are you following? Good. Good. What was R? R was 5 or was it 25? No, R was 5. R squared was 25. Yo, I thought I made a mistake. No, we didn't. It's right. The radius of the one circle, guys, here goes. The radius of the one circle was 5. The other radius was 3. Remember, R squared was 25. Right, Zuhair? Okay. Here goes. So we're done. Right. If x squared, do the last one. If x squared plus y squared minus 6. Now I'm going to show you a shortcut of completing the square here. X squared plus y squared minus 6. Let's do it here on the top. I'm doing question number 5. I'm ending up here with question number 5 before we go into Euclidean. We are at the end now. We are at the end of circle analytics before we start with Euclidean, similarity and proportionality. Right, so what do we do, guys? We're answering question number 5. X squared minus 6x plus y squared plus 10y equals 2. You got to put this into this is not in standard form. This is standard form. X squared x, y squared y equals a constant. So step number 1, put it into standard form. Now we complete the square. Come, I show you a shortcut. Shh. So we do x minus a number squared plus y plus a number squared is equal to 2. Watch. Divide by 2 plus x squared. What you do to x, you do to y. Divide by 2 plus y squared. So 6 divided by 2 is 3. 10 divided by 2 is 5. Plus this x value here squared. 3 squared is 9. 5 squared is 25. And here's your final answer. X minus 3 squared plus y plus 5 squared is equal to 2 plus 9 is 11 plus 25 is 36. So your center, here is it x minus x1 squared plus y minus y1 squared equals r squared. Your center is at 3 and minus 5. You've got to change both these signs. R squared is equal to 36. Therefore, r is equal to the square root of 36, which is equal to 6. And there we go. That's the answer for the last one. So divide the coefficient of x by 2. Divide by 2 plus whatever you divided by 2, you square it on the other side. Divide by 2 plus x squared. Divide by 2 plus y squared. And that's it. That is it. Now let me show you how to tackle Euclidean. So take this one down. Let me show you how to tackle Euclidean. So let's see, are we all okay with analytics there, onliners? You got it correct? Lovely. Absolutely. Well done, well done, well done, well done. Let's go, let's go, let's go, let's go, let's go. Okay. Now, as we enter the dark house of Euclidean. Guys, Euclidean is so easy. Euclidean is so easy. Let me show you. Right. Okay, so what's the time now? It's 25 past 2 already. We only got the last 30 minutes. Let's go, let's go, let's go. Right. Now, let me show you how to tackle grade 12 Euclidean. Let me show you. Shh, pay attention. I'll show you how to tackle grade 12 Euclidean and how to get top marks or top results here. Let's just see. We're exiting. Let's just wait. Is my whiteboard still on? My whiteboard on. My whiteboard on. Let's see what's going on there. It's not responding. Let's see what's happening with my Jamboard. Let's exit the page. Let's reload the page.
Reload, Mr. Kota. Get another tab going.
Reload it. Last session for today, guys, on Euclidean. Let me share this again. I think, let me clear the frame. Let's see, does it clear? I think we're good. I think we're good to go. I think we're good to go. Come on, talk to me. What's going on here? Okay, guys, give us a couple of seconds until, I don't know, Google Meet, whiteboard, Jamboard is gone a little bit.
What you can do, Mr. Kota, you can close your browser and then give it another go.
We're trying it. Let's see.
You're overworking your tools
Something's
there.
happening here. Something's happening here. Let's clear the frame. Let's see. Let's go there. Let's write. Let's go set background there. Let's go here. Let's go blank. Here we go. We are live. Give me a second. Present, share screen. Boom. Let's go. Let's present. We should be live.
Indeed.
We should be live.
You are live.
They're complaining 3 is too early. They want to end around 5.
Good luck with that.
Good luck with that. Okay, here goes. Grade 12. Right, grade 12 Euclidean. Now, grade 12 Euclidean is broken up into your grade 11 component and your grade 12 component. Your grade 11, you're going to get Pythagoras, and that's easy. Then you're going to get your circle geometry, which is so simple. All your theorems. Then you'll get a proof of a theorem. Probably the tan chord theorem or line drawn from center of circle to midpoint of the chord. So you'll get Pythagoras, you get circle geometry, you get theorems proof. Like we said, line drawn from center. Or the tan chord theorem. Right, grade 12, you'll get a proof, similarity or proportionality. In most cases, proportionality proof. So it's easy. Now see, if this is out between say 40 to 50 marks, Pythagoras, you're going to get about 8 marks on that. Circle geometry, another say 12 marks on that. A proof, another, let's say another 8 or 10 marks on that. So 12 and 8 is 20, there's 30 marks. A proof, grade 12 proof, another 6 marks. So you're already sitting with 36. Then you're going to get an easy problem, easy grade 12 problem for another say 8 marks. Then you're going to get one hectic one. So we're already sitting with 30, 44, maybe the easy one, not even so many marks. Let's say 4 marks. Let's say 4 marks there. Let's say a proof, they give you 5 marks there. Then they'll give you 1. So we're sitting on 39 and maybe a hectic one, 10 to 11 marks. And that would give you probably about your 50 marks for your paper. So don't panic. Get your Pythagoras right. Get your circles right from grade 11. Get your proof of grade 11 circle right. Get your grade 12 proportionality right. Get the easy one right. You're already sitting with 40 out of 50. You're sitting with 80% already for Euclidean without even tackling the heavy stuff. Why are you panicking? So get full marks in data, get full marks in trigs, get full marks in analytics and circle analytics. Get 80% here. You're sitting with 96% for your paper. How can you not get a distinction? So now, let's go into the grade 12 component. Let's go into grade 12 work. And please, you do not construct unless it's a proof. The minute they give you a diagram, you use what they give you. Do not go and make your own construction. Right, let's clear the frame. Many of you don't know when to use similarity, when to use proportionality. So it's very simple to remember. Watch here. If you have a diagram and you got a pair of parallel lines, P for parallel, P for proportion. Here you no need, write this down, no need to prove similarity when you're doing a question, unless they ask you for the proof of it. But here you can use proportion as a reason without having to prove similarity. Because the minute one side is parallel to the third side, we know that over that equals that over that, or this over its whole side is equal to that over its whole side. We're going to do problem. So I'm just showing you when to use proportion, when to use proportionality or similarity. So when you see parallel lines, you use proportion. When you see a triangle like this, let's just say this happened in a circle, right? And you see another triangle like that. And let's say there was a circle going around. Okay, that's supposed to be a circle. It looks like an egg, but it's a circle, right? Now you got triangle A, B, C, D. Now when you got one triangle superimposed, and when you got to separate triangles, you see here you need to prove triangle ABD when you need to prove triangle ABD similar to triangle BCD. You've got to separate the triangles. And when you separate the triangles, you've got to use similarity. S for separate, S for similar. Now you've got to do it like congruency. Now you say, in triangle ABD and triangle BCD. So when you see parallel lines, it's proportion. When you see superimposed, S for superimposed, then you separate the triangles. Then you use similarity. Does it make sense to you? Now let's do some problems. Let's do some examples. So now that we understand when to use it, the minute you're going to see parallel lines, you're going to tackle proportion. The minute you see one triangle on top of another in a diagram or in a circle, you're going to separate the triangle, you're going to prove similarity. And to prove, we only need to prove two angles. The remaining angle will automatically be equal, because sum of angles of a triangle add up to 180. Yes or no? Good. So we're all on the same page. Right, now get ready. You've taken this down. You've understood when to use proportion, when to use similarity. Good. Analytics. Hey, these people are gone. By this time of the day, they are gone. The brains are fried. Right, let's go, let's go, let's go, let's go, let's go. Right, we're clearing the frame.
I like my chips crispy. Well
Yes,
done.
you like
Fried
those?
well.
Well done. Let's go, let's go, let's go. Right. So let's say, here's a simple one. I'm going to give you about 2 or 3. Let's do 3 in proportion. So here's question number 1. Let's see how simple. Let's see if you can understand. This is the easy one. There we go. That A, B, C, D, E. A, B, C, D, E. 6, 4, 2, 6, 4, 2, x minus 5. Find the length of BD. Find the length of BD. So that's easy. This is a level 1 question for 4 marks. Remember, they don't want you to fail. So they're going to give you some easy stuff with big marks. It doesn't mean it's difficult. Now, this is the way you answer it. You now state triangle AED is similar to triangle ABC. Right? Now you say proportionality, proportion theorem or proportionality. Because you've got a pair of parallel lines. Therefore, x minus 5 over 6 is equal to 2 over 4. Let's solve, right? That over that is equal to this over that. So x minus 5 is equal to 2 times 6 over 4. X minus 5 is equal to 2 times 6 is 12. 12 divided by 4 is 3. X is equal to 8. Therefore, BE, not BD, they wanted BE. They wanted BE. Therefore, BE is equal to x minus 5. We solved for x. X was 8 minus 5. BE is equal to 3 units. Simple. This was a level 1 question. And not to say that your level 1s won't be asked in your exam. Not to say that your level 1s won't be asked in your exam. Let's go on to a level 2 proportionality. Let us go on to a level 2 proportionality. Onliners, are you following? Onliners, are you okay there? Now look at Maklatsi, what he says. Euclidean, you can pack your stationery and leave the exam room, shame. No, man. No, man. No, man. No.
Toasted.
Right. They toasted already. Right, I'm clearing the frame. I'm clearing the frame. Let's go to the next one. Here we go. Take this one down. They love the next question where they give you 2 pairs of parallel lines in one triangle. You've seen this one before. A, B, C, D, E, F. A, B, C, D, E, F. That's 10, that's 12. That is parallel to that, and that line is parallel to that line. They tell you ED is 6. Find the length of AC. Find the length of AC for 6 marks. So they want AC, the entire length. Now, whenever you got two sets of parallel lines, you have to work with the two triangles differently. Shh. Right, so take this one down. I'll give you a minute to take it down. Right. Guys, we don't have much time. It's 22. I still want to do one. So I've done two proportionality and then I'm going to do one similarity from the exam. But that one is quite a bit of marks. It's 16 marks. So I want to end up with the 16 mark similarity problem from a past paper. Right, so let's go here. Shh. Let's look at this. We want AC. We want that entire length. I'm going to start in this triangle first with these two parallel lines. So obviously I need AE. So I know I'm going to start it off like this. In triangle, which triangle are we looking? ABD. ABD. We know that AE over ED, AE over ED is equal to AF over BF, is equal to AF over BF, proportionality. So I need AE over what's ED? 6. AF is 10. FB is 12. So AE equals 10 times 6 is 60. Divided by 12 is 5. So AE is 5. Now let's go into our big triangle. In triangle ABC. ABC. And now we're looking at the big triangle. And we're looking at these two parallel lines. So obviously we need DC. So DC over DA, DC over DA will equal to BF over AF. So DC over what is DA? 6 plus 5 is how much? 11. BF is 12 over AF is 10. So therefore DC on its own is 12 times 11 over 10, which is equal to 132 over 10, 13,2. I don't know, check. 13,2. So DC is now 13,2. They want AC. Therefore, AC is equal to 5 plus 6, 5 plus 6 plus the 13,2 which we just found. 11 plus 13,2 which is equal to 24,2 units. And there we go, you got yourself 6 marks for that. And there you go, you got yourself 6 marks for that. We work with the two lines in the two parallel lines in the different triangles separately. How's it going, onliners? How's it going, onliners? We're almost at the end. We're almost at the end. Very fanta. I learn new language and lingo here every day, bro. I'm selling my brain for 1.2 million a pop. Anybody up for it? Take it. Take it. Give it to me in December. I'll lease my brain. Maybe, who knows? Maybe we can do Neuralink. Maybe Elon Musk will come up with Neuralink. Let's go. That one's done. Take the next diagram down. Here's it, the last one for today. Right, so we have a circle. Let's go, let's go, let's go. This is the last one for today. So we got a straight line coming down from here to here. We got a line going from there to there. That's a tangent. They tell you that's 90 degrees. They give you a line coming down from there to there. They got a from here to here. Take this one down. They got a line from there to there. They got a line going up from there to there. They got a line joining these two. And that's the diagram. They tell us that's also 90 degrees. A1, A2. D1, D2. M. C. That line is equal to that line. This angle is X and that is point B. Right. In the diagram, A, B, C, D is cyclic. A, B. They're already telling you, use the rules of cyclic. The minute they tell you A, B, C, D is cyclic, they're already instructing you, use cyclic quads to answer your question. AC is perpendicular, DC equals CB, AD is produced. Those two are perpendicular, let B equal to X. Right, here goes the questions. Number one, prove that MC is a tangent. That MC is a tangent to the circle at point C. Number two, that triangle ACB is similar to triangle CMD. Now here we probably will have to separate the triangles. Now the big questions. So that's easy, that's easy. Question number three, prove that CM squared over DC squared is equal to AM over AB. That's your first one for 6 marks. And question number four, that AM over AB equals sine squared X. 5, 3, 6, 2. 5, 3, 6, 2. There's your mark allocation. There's your mark allocation. Let's go, let's go, let's go. Right, give it a go, give it a go. So let's answer question number one. We need to prove that MC is a tangent. So the only way to prove that MC is a tangent, we need to prove that that angle there, angle between tangent and chord, is equal to the angle in the alternate segment. So we need to prove that DCM is equal to A1. If I can prove that, therefore MC is a tangent. How do we do that? How are those two angles equal? How are you going to prove? How are you going to prove that this angle here is equal to that angle there? Then you'll get your 5 marks. Okay, I know. Obvious. All right, let's answer question number 1. Shh, because we don't have time. So if I look at these two triangles, if I look at triangle DMC and triangle ABC, we know that angle D2 is equal to angle X. Why? Angle D2 is equal to angle B, which is equal to X, exterior angle of a cyclic quad. So this is X. That's 90, that's 90. 90x, 90x. Obviously, the last angle, sum of angles of a triangle, must be equal. So angle C is equal to 180 minus 90 plus x, which is equal to 180 minus 90 minus x, which is equal to 90 minus x. So C is 90 minus x. Oh, wait, ABC. No, but then I got 8. Oh, I know. Oh, wow. Wow. Okay. Okay, so yes, in ABC. So I'm going to find A2. Watch here. So angle A2 is also 180 minus 90 plus x, sum of angles of a triangle. Sum of angles of a triangle. This is also sum of angles of a triangle. So angle A2 is also equal to 90 minus x. So this angle is 90 minus x. Now look here, something you guys didn't see. Equal chords subtend equal angles. Therefore, angle A1 is also 90 minus x. Equal chords subtend equal angles. Therefore, angle C is equal to A1. Therefore, angle C equals angle A1. Therefore, MC is a tangent. MC is a tangent. And that is the converse of the tan chord theorem. Converse of tan chord theorem. So if an angle between a line and a chord is equal to the angle at the alternate segment, therefore the line must be a tangent. It's the converse of the tan chord theorem. I thought I won't see that one. Well, we saw it. Right, you carry on. Prove angle ACB. Similar to triangle CMD. Where's ACB? ACB, CM. Done. We did it already. We proved that the three angles, we just proved that the two triangles are similar. But in any case, they're asking it to us again. So never mind. We'll get another Mahala 3 marks. We're going to get another Mahala 3 marks here. Dudu, if your screen is not clear, it means your internet connection is bad. You guys can re-watch this on the YouTube Awqaf channel. Right, let's go. Let's go. So we already proved this one, guys. I'm erasing here. We're answering question number 2. But they're asking you for the proof. So now you got to write the proof out. Here you can't say prop or you can't say proven above. They're asking you for the full proof. So let's go for the full proof. That's 90 minus x. Right, we're answering question number 2. in triangle ACB and triangle CMD. Number one, ACB, right? And A and CMD. That's M, nah? Where's M? M is here, nah? CMD. Right, let's go. ACB. So that means angle C is equal to angle M, which is equal to 90 degrees given. The second angle, ACB, angle B, is equal to angle D2, which is equal to X. Exterior angle of cyclic quad equal to interior opposite. Exterior angle of cyclic quad. The last one, the remaining angle. Therefore, angle A2 is equal to angle C, DCM. DCM, remaining angle, the last angle. Therefore, triangle ACB is similar to triangle CMD. Done. So we're done with that one. We're done with that one. Right. Just call this one C1, C2. Let's call that C1. And just for explanation purposes, let's call this angle here angle C2. Right. We're almost done, guys. Shh, girls, ladies. Right. Let's prove that CM squared. Right. I'm writing it here on the top. I'm going up to the top again. Prove that CM squared, here goes. Prove that CM squared over DC squared equals AM over AB. That's what we need to prove. Right, we got triangle ACB similar to triangle CMD. Let's see. We're almost at the end, guys. We're almost at the end. So this was the CM squared. Right. A1 equal to C2. Okay, we proved that this was 90 minus X. We proved that that was 90 minus X. M is common. C1 plus C2. C2. These two triangles are similar here, guys. CM squared over DC squared. CM squared over DC squared is equal to AM over AB. But let's leave the AB out. In fact, I'm going to look at these two triangles. So let's look at this. Let's look at this. Now, this is what we do. I'm looking at these two, right? So this is what you can do in the exam. Break it up like this. That's your one triangle. AMC, AM, and this is the whole of C. C1, C2. Then split it up because we're looking at the small triangle there. We're looking at the small triangle there. That's 90 degrees. That's D2. That's M. And that is only C2. Right. So now we need to prove similarity. So now we say in triangle AMC, and that's also 90, and triangle DMC. What do we have? Angle M equals angle M, right? Angle M equals angle M 90 degrees. Angle M is equal to angle M, which is equal to 90 degrees, and it's a common angle. Number 2, give me another angle that's equal. C2 and A1. Right, so AMC, A1 is equal to C2. We proved it, 90 minus X. Angle A1 is equal to angle C2, which is equal to 90 minus X. We proved it above. Or we can even say tan chord. So now pay attention. So you got 90 degrees, you got A1 equal to C2. So I'm going to do this. I'm going to put a tick, I'm going to put a tick. I'm going to put a full circle, I'm going to put a full circle. So the last remaining angle is angle C1 plus C2. Therefore C1 plus C2, I'm going to put an open circle there, is equal to angle D2. Is equal to D2 remaining angle. Now be careful now. Therefore triangle AMC. Now watch here. AMC, full circle, tick, open circle. Full circle, tick, open circle is similar to triangle, full circle, tick, open circle. It must be corresponding. So full circle, C2, tick, M, open circle, D. So you can't say DMC. You have to say CMD. Are you guys with me? Right. So now here comes our proportionality. Therefore CM over DM. Therefore CM over DM, because they want CM there. CM over DM is equal to AM over CM. Now we can cross multiply. I get CM squared is equal to AM times DM. Right. Now in our previous question, I'm just going to move over here to the top. Pay attention. We're not yet done. We only got our first condition. We got our first condition. Our first condition, CM squared equals AM times DM. Now in our previous question, what was it? Triangle ACB or ABC was similar to triangle CMD. So therefore DC over AB is equal to DM, where's DM? DM over CB or BC. Therefore, cross multiply, DC times BC equals AB times DM. Right, wait, we're not yet done. That is from the previous question. From the previous question. Right, can I erase here? I want to finish up. Right, let's go. I'm erasing that. Right. But we know that DC is equal to BC. We know it's given to us that DC is equal to BC. Here we go. But DC is equal to BC. DC is equal to BC given. Therefore, instead of BC, I can put DC. DC times DC is equal to AB times DM. DC squared equals AB. Let me just write this properly, times DM. AB times DM. So if I divided the two, what did they want? CM squared over DC squared. So CM squared over DC squared. Therefore, watch here. CM squared over DC. So let's call this equation number 1, equation number 2. They want you to divide equation number 1 divided by equation number 2. So CM squared over DC squared is equal to AM times DM divided by AB times DM. Now DM and DM cancels out and there's your answer, AM over AB. There's your answer. So we use the two proportionalities. We divided the two proportionalities and we got the final answer. But like I said, you will leave this question for last in your exam. If you got time, you do it. If you don't have time, don't do it. What was this? C2. How much time do we have? Oh, it's 3:05. We started a little bit late. Let's finish up the last one. You want to wrap up now? You guys tired? Your brain's fried. Hasanain, how are we for time, bro?
I think we can do another one. I think our online are quite
Can we
keen.
finish that last one?
Yes. Go.
Let's
Go.
finish that last one. Where AB over AM equals sine squared. Let's finish this one. So you took this one down. Let's wrap up. Let's wrap up with that last one. Let's wrap up with the last question there.
Question.
What did they want you to prove? What question number was this? Question number 4. They wanted you to prove that AM over AB is equal to sine squared x. Now, how many marks did they give you? No, it's probably about 3 to 4 marks. I don't know why they gave only 2. There's quite a bit of working out there. Right, we're almost done, guys. We're wrapping up. We're on to the last question. Right. Right. Let's look in triangle. We're finishing up. In triangle DMC. Let's look at triangle DMC. Now remember, this is x. So D2 is also equal to x. D2 was equal to x. We proved it to be x. Right. So sine D2, sine of angle D2, because we talk about sine D2, which is sine of angle x, is equal to opposite over hypotenuse, MC over DC. MC over DC. So therefore, sine squared x is equal to MC squared over DC squared. But in our previous question, MC squared over DC squared was equal to AM over AB from the previous question. Oh. Therefore, there's your final answer. Sine squared x. That is sine squared x is equal to AM over AB. Bada bing, bada boom. Okay, don't pack up yet. Don't pack up yet. Okay, you can pack up. We're at the end, but don't leave yet. We just want to do our final vote of thanks for everybody. Right? There's a few things I just want to discuss with you guys also for a minute or two when we are done. So I just want to say Jazakallah, and let's check out all our onliners. We are done. We've officially ended. Good luck to everybody. Denzel wanted extra time, hasanain. I just want to say to all our learners, well done, well done, well done. 2 days we've become familiar. And we hope to see you guys. I hope it was a great experience. I hope you guys enjoyed it. And inshallah, by the grace of God, may the Almighty make it easy for you. And may you all get your distinctions in your exam. From me, Mr. K, Kway Institute, we just wish to say thank you to all. Love you lots. Lots of love from us. And you know what? God bless. And do yourself and do us proud. Thank you so much.
Here we go. That was Mr. K. Thank you so much, Mr. K. So that was the grade 12 online maths workshop hosted by Awqaf South Africa in association with the Department of Education, Mr. Kota from the Kway Institute, as well as iSkill. And we've been graciously hosted at the Ghazali College by Principal Mr. Muhammad Riza Ibrahim. He's been doing a fantastic job. I would like to extend our vote of thanks to the Awqaf SA team, our CEO, Sadiq Isaacs, our Deputy CEO, Mikhail Collier, as well as Shireen Ariftin, Ali Masango. Would love to extend a vote of thanks to our service provider, Mr. Ibrahim Samodin from Mobi Sound. He's been assisting us with the technical parts of bringing us this hybrid event. So don't forget to subscribe and like our YouTube channel. We will be conducting more workshops for the prelim as well as the final examination. Log on to Awqaf's website, awqafsa.org.za. We'll have the videos of the past session. Next week, we'll have a session for the grade 10 learners. So look out for that. So we're just going to be concluding now. And I would like to thank Mr. Kota for his energy, his enthusiasm, his energy, and his dedication. And I'm going to play some of these comments over here. Lemons is saying thank you. Veron Tami says thank you. Love you guys. Love you too. Wish you guys all the best. Fly the flag high for South Africa and do us proud. And really, we would love for you also to take part in the our competition that we are hosting. So if you have registered, we'll definitely send you confirmation of that. I'm just going to play a video. This is the video of how we started off the session this morning.
South Africa, South Africa. Die blauw van onze hemel.
There we go. That's some photos from the Ghazali College. of some of the
You
learners.
are there.
So there we
You,
go.
there you.
Mr. Kota, you guys having an after party there? What's happening there?
Yeah, no. They just enjoying everything. They saw themselves all on the screen. They are going crazy when you played the national anthem.
Yeah, so I think we should be doing more of this to start off the session. Started from a point where we are proud for our country. And look, essentially, this is an exercise in nation building, supporting our grade 12 learners, and they are our future.
Absolutely. To all our learners from across the country, teachers, parents, whoever was engaged in the program, we especially want to thank the Department of Education as well as Awqaf South Africa for making a program like this possible.
Salute!
And hasanain, my
Salute.
co-pilot, always there, always energized, always right through the entire 2-day program. And guys, relax. We always say, like, subscribe the Awqaf YouTube channel. You'll get the recordings for the 2 days on there. You can watch it over and over and over again. As well as, remember, we coming back, guys. We're back for you before prelims. And we're back before finals also. And that, it's only higher order questions. Before prelims, before finals, we are only cracking past papers with you. So guys, I hope do us all proud and God bless. Jazakallah so much.
So there we go, Mr. Kota. We'll see you on the other side. We'll see you for the grade 12s next week. And
Grade
thank
10.
you for your energy.
Grade 10.
Grade 10, yes, my correction. So next week, if you got any siblings, we do have a grade 10 workshop. It will be hosted via live stream. So connect to myself and Mr. Kota, and then you will get some of that energy over there. Anyway, Mr. Kota, all the best.
Jazakallah.
Rest up.
Thank you so much. From us in studio and from Ghazali College, Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, Totsins, Giabonga. Good luck.
Okay, all the best, guys.
Salam.
See you. Okay, Assalamu alaikum wa rahmatullahi wa barakatuh.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care.